Yes, so let's go ahead and come back. Let's see if we can get the people out here. So we're going to have, just let me give you a little bit of background. Vamos a tener a Luis Marín. Vamos a tener un desarrollador local con nosotros. Es muy bien que tengamos las presentaciones que nos trae el Departamento de Energía, pero siempre es bueno tener pues presentaciones que tengan ámbito local. Ayer tuvimos una presentación del Consorcio de la Montaña. Ahora tenemos una presentación con nosotros de un desarrollador local, Luis Marín, el cual él desarrolla facilidades a nivel de utilidad. Algo que vamos a estar con él compartiendo hoy son las oportunidades que los mapas de Hosting Capacity le brindan a él para poder identificar esas áreas donde se hace más beneficioso la interconexión de estas facilidades, ya que estas facilidades pueden proveer servicios a la utilidad donde haya restricciones. Tenemos atrás en un mapa, hablamos del mapa del PIR del 2015, es una simulación. Los alimentadores son representativos de las piedras. Claro, estuvimos hablando del GIS, esto fue en el 2015, después del 2015 no sabemos si debido a María estos alimentadores se han movido de alguna manera. Pero en el 2015 esa era una buena radiografía de los alimentadores de distribución para la subestación de las piedras. Ese mapa nos da unas restricciones, el cual Luis Marín, que trabaja como desarrollador en la isla, le puede dar información de dónde podría ubicar sus facilidades y qué clase de servicios le podría brindar a la utilidad que fueran beneficiosos para la red pública. Así que le dejo con Luis Marín esto es como discusión, así que esto es abierto y es un conversatorio. Gracias.
Gracias, Jorge. Yo llegué un poquito, ¿verdad? Llegué ahora en el segundo turno, pero me gustaría, ¿verdad?, que se presentaran los que ya yo conozco a los compañeros del Departamento de Energía, pero hay otros compañeros que no tengo el placer de conocer sus nombres. So if we could do a round table and just mention your names again, would be good.
Irán Medero, director de Tecnología, Energía Eléctrica.
Hey, good afternoon. Omar Sadeh with Accenture.
Hola, bienvenida.
What do I need to say?
Your name.
Laura, from CESA, the Solar and Storage Energy Association of Puerto Rico.
Jesús Peña, ingeniero supervisor en la Autoridad de Energía Eléctrica.
¿Cómo tú estás? ¿Estás bien? Bien. Nada, buenas tardes. Tomás Vélez de la Autoridad de Energía Eléctrica.
John Jordan with National.
National? Yeah. And that's okay. A fund? New York. A fund from New York? A funding? Insurance. Oh, insurance.
My name is Dr. Hasty, Julia Hasty, and right now I'm a project manager for renewable energy projects.
What company?
Two different clients.
Great. Welcome.
Hi, Carolyn Brulard from ICF, here on behalf of DOE.
Hello, Joe Palladino with the Department of Energy, supporting this effort.
Hola, Patricia Acosta con ICF, supporting DOE.
Tom Memna from ICF, supporting DOE.
Great. My name is Luis Marin. I'm a professional engineer, licensed engineer, background in energy and power and some controls.
La presentación la puedes hacer en español o en inglés, como tú quieras, porque se está traduciendo. Como te sientas mejor.
Questions are welcome in Spanish or English, no doesn't matter. Pues venimos a compartir con el negociado de energía y en esta ocasión pues podemos traer unas experiencias, ¿verdad? Del sistema de interconexión y de la manera en que la visibilidad de interconectar la capacidad, hosting capacity, nos puede ayudar a todos, al negociado, a la utilidad y a el ambiente que se está incrementando en que los renewables, ¿verdad?, vayan incrementando su inserción en la red en Puerto Rico. Tenemos un mapa en la pantalla que, ¿verdad?, quiero preguntarle a Tomás, pedirle un backup. Tomás, este mapa de las piedras obviamente es a priori al evento de María. Podemos asumir que quizás hay un 60% de veracidad, ¿verdad?, en cómo las líneas quedaron, ¿verdad? Quizás hay un brinco por un huracán ¿verdad?, una reparación, pero más o menos ese comportamiento de línea pudiera ser más o menos veraz.
Sí, yo creo que la representación del circuito, que era el que teníamos, ¿verdad?, para el 2015, ciertamente la configuración actual debe ser similar a lo que tenemos allí. Sí.
Entonces, el comportamiento que vemos del voltaje y este comportamiento en este branch, cuando usamos esta nomenclatura, todavía mantenemos la nomenclatura 2801, ¿eso sería qué voltaje?
Sí, ese circuito se alimenta a voltaje de 8.32 kV. Ese nivel de voltaje lo tenemos típicamente en el área de Caguas, Las Piedras, hasta el área de Humacao, en Puerto Rico.
Ok. Uno de los ejemplos que podemos mencionar sobre este mapa y el comportamiento es que la utilidad, en este caso prepa, pues al encontrarse alguna condición como esta, tendría unas necesidades, ¿verdad?, y unas oportunidades que enfrentar. Entonces, ¿cómo le damos un giro a cómo nos pueden ayudar las renovables? En este caso, y las tecnologías modernas, ¿verdad? En este caso, si nosotros tenemos una cantidad de voltaje en una presencia y en una situación, creo que esto es a las horas picos del sol del día, probablemente quizás hay un comportamiento de clientela en esa área, ¿verdad? No tenemos aquí la otra imagen interpuesta de regional, pero en esta región, pues quizás en estas áreas no tienen el problema porque no está la población en consumo tan alto o no está la inserción tan alta. Pudiéramos asumir que hay una inserción alta de voltaje por renovables o por generación. Y los niveles están altos aquí. Probablemente con un sistema de energía renovable pudiéramos identificar en un mapa como este que tuviéramos una capacidad disponible a la cual le pudiéramos quitarle un poco de este voltaje haciendo almacenamiento de baterías, haciendo uso de un relevo hacia otros lugares, ¿verdad? En el caso de la utilidad tendría que buscar soluciones de cómo bajar esos niveles, ¿verdad?, si se va por encima de lo que presta, y conllevaría una inversión. ¿Verdad? No sé si quieras darle una idea por encima de cuál sería una de las soluciones si fuera estrictamente ustedes solos, ¿verdad?, la utilidad, sí, tratando de solucionar esta condición.
Sí, ¿verdad? Parte de las soluciones, por ejemplo, si tú encontraras una condición donde puedes tener, ¿verdad?, unos niveles de voltaje que vayan por encima a lo que establece el estándar de ANSI, el C84.1, nosotros consideramos entre las opciones, ¿verdad?, para permitir acomodar sistemas adicionales de generación distribuida. Una podría ser balancear las cargas del circuito. Ahí veo que el área que está limitada es la fase A de ese ramal. Tú podrías tratar de balancear la carga en esa área. Podrías también extender conductores adicionales y en vez de tener esas cargas supliéndose a través de un ramal monofásico, podrías hacerlo a través de un ramal trifásico, donde entonces distribuyes mejor la demanda en el área. También puedes considerar la instalación de un regulador de voltaje, pero de nuevo, cada una de estas diferentes opciones pues implica una evaluación, ¿verdad?, detallada y una inversión que se tendría que hacer para quizás acomodar esa generación distribuida adicional.
En base, ¿verdad?, como lo compartimos, el expertise de Tomás y del el grupo de la utilidad. En esta área, por ejemplo, eso que menciona él podría conllevar unos estudios y unos gastos. Entonces, ese gasto, obviamente planificado, diseñado, pudiéramos nosotros tomarle ventaja de que en ese sector, si nosotros tenemos esta cantidad de comportamiento en el voltaje y pudiéramos arrancar un poco ese voltaje haciendo un resguardo en batería, por ejemplo, y ayudar a bajar ese nivel que va borderline, ¿verdad?, está marginal a lo útil, pudiéramos hacer una ayuda en la cual tiene la inserción de renovable o sostenible y además no tendría que conllevar una inversión capital. O sea que ahí tendrías un modelo en este hosting capacity que te da una virtud y un retorno a la inversión, porque la autoridad no tendría que, el utility no tendría que invertir tanto en esas áreas. Al igual que en las áreas que tenemos, ¿verdad?, un comportamiento que está marginalmente aceptable, pudiéramos compartir, como él dijo, de la inteligencia que tienen los sistemas de energía renovable, que ahora tienen la inteligencia de ser, se pueden comunicar, y creo que ya estamos a nivel, en California es el Act 21 o algo así, ¿verdad? Exacto. Que toda esa inteligencia pudiera estar a favor de nosotros y en los lugares que está, de una manera, ayudar a minimizar estos comportamientos. También el sistema de hosting capacity, si estuviera para implementación, no tendría que estar al costo de la utilidad, porque pudiera ser hasta un proposal privado, donde permitiría que hayan otras ideas y hayan otras iniciativas para poder hacer las marcas a los mapas y uno poder entonces traer inversión y traer otro tipo de modelo económico que conlleva beneficio para la utilidad, beneficio para la resiliencia del sistema y beneficio para el camino que nos hemos marcado de llegar a un alto por ciento de renewables en 30 años, ¿verdad?, que nos quedan.
Una preguntita rapidito a Luis.
Queremos we wanted to be interactive, so let's go to questions.
Yeah, algo que te iba a preguntar, como desarrollador, ¿no? Cuando tú miras ese mapa, ¿no? O sea, tú tienes tus metas de, pues, instalar la facilidad más que puedas instalar y potencialmente, pues, darle ayuda y darles apoyo a la red eléctrica. Cuando tú miras un mapa como este, el cual ya tú ves que hay unos sitios, puede ser hasta laterales de ese ramal, donde hay unas presencias de voltaje que están borderline, como dices, ¿no? ¿Tú ves esa información como oportunidades para poder identificar dónde es que podrías tú interconectar, o sea, construir tus facilidades, por ejemplo, de almacenamiento? O sea, de almacenamiento tienes que cargar las baterías, ¿no? Y al cargar las baterías, pues sería una buena oportunidad para depress el voltaje que está en amarillo. O sea, si nos puede dar un poquito de cómo es que quizás esta información te podría ayudar a ti, primero que nada, a localizar dónde podrías construir tus facilidades y segundo, pensar en qué clase de servicios le podrías brindar a la red.
De prima facie, ¿verdad?, a primera mirada, estos mapas y la interposición, ¿verdad?, con el satellite imaging, pues tú puedes hacer una planificación inicial de dónde pudiera ser posible ofrecerle a la utilidad lugares donde sea conveniente la combinación de almacenamiento, MTRs o ATRs, y también donde la carga, por ejemplo, si allá la carga, otra manera de relevarla es sustituyendo la inyección que está teniendo de energía, pues aquí, allí y allá crea diferentes escenarios de oportunidades. se sabría inicialmente y se puede planificar. Después entonces hay unos pasos que uno se acerca al equipo de trabajo de la utilidad y entonces intercambia esas opciones, ¿verdad? En este caso en Puerto Rico hasta ahora es así. Y uno intercambia impresiones y ustedes dicen, Luis, aquí sí, tienes razón, es desired, lo deseamos, es conveniente para ambos, crea la oportunidad y desde el punto de vista de desarrollo, las personas que están interesadas en eso, en esas inversiones, pueden participar de este crecimiento hacia los renewables. O sea, básicamente estos mapas son clave y son de la importancia más alta si logramos que se generen en los próximos, en el próximo futuro cercano.
Porque es interesante, el mapa parece que son tres cosas, yo creo que el mapa nos deja saber. Este mapa nos está dejando saber primero que dónde pueden ser las localidades que son deseables, ¿verdad? Para suplir un tipo de servicio. En este servicio, el servicio sería, cómo vamos a dispersar el voltaje, ¿listo? Podemos dispersar el voltaje durante el día cargando baterías. Este mapa también nos podría dar información, como lo estamos viendo, que probablemente instalar más solar donde está amarillo y rojo quizás no hace sentido porque ya estamos, ¿no? Vamos a subir más el voltaje. O sea que un mapa así nos puede dar claridad del tipo de servicio que se puede utilizar, la clase de facilidad que se debería proponer y probablemente la localización, la localidad deseable para estas facilidades. Esto como desarrollador, o sea, ¿esto te ayudaría a tu planificación y a ser más eficiente?
Es de utmost importance. Esto es súper importante. Si no hay dónde arrancar, no puedes planificar. Esta es la primera bitácora, el primer camino de información para no empezar a planificar. Y a planificar las inversiones y el desarrollo.
Y te iba a preguntar, Tomás, o sea, mientras estás planificando el sistema, ¿no? O sea, tú vas a tener ese tipo de data porque eres la utilidad. ¿Dónde están las oportunidades? Por ejemplo, Luis mencionó algo muy importante. Te recuerdo que me estabas hablando que si tú fueras la utilidad, ¿qué tú harías entonces? Si tú fueras entonces la utilidad.
Bueno, en este caso, por ejemplo, si tengo un área que la tengo muy alta, como mencionó Tomás, habría que buscar el estudio, planificación de cómo resolver estas áreas. Pues ya eso te conlleva una inversión y una atención que te quita de otros desarrollos. Y después tienes que buscar una solución física o de planificación del sistema que puede conllevar a mejoras de unos costos y un tiempo, ¿verdad? Sustancial. Por lo tanto, en este caso, si tú tienes un área como esta, quizás la tienes que aliviar entre tres lugares para que se balancee un poco y aquella área obviamente no puedes permitir más inserción de energía porque va a seguir subiendo el voltaje.
Entonces, ¿a dónde es que queremos llegar?
Sí, yo creo, ¿verdad? Cuando, por ejemplo, cuando este mapa se trabajó, que eso fue en el 2015, ¿verdad? Esto fue aunque el circuito era de nosotros, quizás la parte de pintar por colores el circuito, eso lo trabajamos con el personal de Siemens, que fueron los que trabajaron el plan integrado de recursos en aquel momento. El propósito principal era poder identificar cuáles eran esas áreas donde podíamos encontrar situaciones de sobrevoltaje ante una integración grande de renovables. Que quizás ese era su propósito primordial, ¿verdad? El enfoque era, vamos a identificar cuáles son esas áreas, esos spots que podemos encontrar sobre voltaje. Pero fíjate que el mapa tú también lo podrías utilizar, como estaba mencionando él, que tú puedes visualizarlo, cuáles son esas áreas donde quizás nosotros como utilidad podemos tener, en vez de sobrevoltaje, en qué lugares tenemos situaciones de bajo voltaje y cómo en esos lugares, ¿verdad? Pensando en el escenario que estamos viendo, que esto es a mediodía, ¿verdad? ¿Cómo podríamos nosotros, no necesariamente utilizando reguladores de voltaje o cualquier otro tipo de equipo, sino, por ejemplo, con sistemas de generación ubicados en esos puntos de bajo voltaje, qué ayuda ellos le pudieran dar al circuito para mejorar el nivel de voltaje que por lo menos, por ejemplo, tuvieras tener en un escenario del mediodía? Ciertamente esto es una foto, ¿verdad?, de un momento en el tiempo al mediodía. Esto siempre, como habíamos hablado ahorita, tenemos que complementarlo a cuál es el efecto cuando no está el sol, que esa generación que proviene, ¿verdad?, de la fuente renovable de energía no está. ¿Qué efecto tendría el que entonces esa generación no esté ahí en ese momento por las noches, por ejemplo? ¿Cuál es su efecto? ¿Hace falta equipo nuevo o no? Por ejemplo, instalar un regulador de voltaje o añadir generación en ese punto, ¿resuelves el problema? Yo creo que por lo menos esto nos da una idea general, ¿verdad? Por lo menos desde el macro, cuáles son las opciones que tú puedes ir auscultando para entonces después irte al detalle. Por lo menos te da una idea general y después obviamente tú te vas más al detalle en el análisis, pero ciertamente es una herramienta que entendemos es útil porque fíjate que físicamente con tú ver esa foto, ya tú sabes que en esa área a la derecha tenemos unas limitaciones ya para integrar generación al mediodía, que hay que buscar una solución, ¿verdad? No podemos quedarnos pensando de que tenemos ese problema y pues no voy a dejar que nadie se conecte allí. Esa tampoco puede ser la mentalidad. Para eso están los ingenieros.
Sí,
¿verdad?
no, pero a prima facie, para un
Da una
plan en el momento,
Te da una
te
idea.
da una imagen.
Una idea de la situación que tienes y así mismo identificas otras áreas que quizás no están relacionadas con generación distribuida, pero problemas que puedes ver, lo puedes encontrar con simplemente viendo visualmente, ¿verdad? Esa imagen.
Me doy cuenta que es un área rural poco poblada y está la roja, el círculo bien rojo.
Sí.
Y entonces invertir en infraestructura ahí, pues...
No.
Quizás no hace sentido en ese instante.
Digo, te tengo que decir la verdad.
Sí, por eso mismo,
Por
¿verdad?
eso es que da una herramienta para planificar.
Tomas, could I ask a question there?
Sure.
The question is. Sorry, I'm not listening to myself.
Yeah, I know.
So the work done by Siemens here, was this a forecasted or was it an existing case with the highest voltage during that low load?
We did that analysis, 4 years ago. I know we did analysis based on the current situation on the feeders, but we also did analysis on with additions of DG systems beyond the ones we had already installed on the system. In that particular feeder, I would have to see the report. I don't remember really. It's just that we run so many load flows for Siemens for performing these maps. I don't remember now. I would like to see the report just to refresh my head here. I don't remember if that was an actual condition that we had on that feeder.
Oh, no, I do know that. It's actually modeling.
Modeling.
Totally,
Oh,
totally
okay,
modeling.
yeah.
Yes.
Yeah, it's just that I remember.
totally
that-
model, yeah.
It's just that I remember we did different kind of analysis for them, where we presented the low flows of the current situations we had with feeders, but also we performed analysis where we were aggregating or adding more DG systems on different spots on the feeder just to see the effect of that on the voltages of the feeder.
Right.
And based on what Camacho is reminding me, then in that case, it would be that for that particular case, then we were adding DG capacity at some point on that eastern part of the feeder to see the effect of the voltages while we were increasing the capacity of the DG systems while leaving the regulation of the feeder at the feeder head steady at 1.05 per unit.
So again, it served as a planning tool. Otra vez es una herramienta de planificar que si modelabas insertar generación distribuida en esta área, cuál era el comportamiento a través del feeder. Entonces, a las personas que fueran a ser clientes de un desarrollador como nosotros, que me preguntaran por esta área de por acá, yo pudiera decirle que la planificación iba a correr más rápida con mi amigo, y él tendría una herramienta de decirnos, mira, aparentemente lo que quieren interconectar en esa área, aparentemente, ¿verdad? Se ve bien.
Sí,
Tendría inserción.
Sí, yo creo que este tipo de mapa, ¿verdad? Donde tú puedes visualizar lo que tú tienes y, ¿verdad? Las limitaciones que puedas tener en un circuito, ciertamente es beneficioso tanto para, ¿verdad?, el que está afuera, que puede conocer, ¿verdad?, si su área está limitada en cuanto a la integración de generación adicional. Y en el caso de nosotros, pues volvemos, nos da una idea clara, ¿verdad?, de forma general, si una adición de generación distribuida en algún punto en ese circuito, pues nos puede traer problemas o no. Por ejemplo, todas esas áreas que están en color verde, pues básicamente el voltaje está dentro de lo que establece el estándar de ANSI C84.1 y tú pues te preocupa menos la cantidad quizás de análisis que tienes que realizar si la capacidad que tú vas a interconectar en ese punto está por debajo de lo que puede absorber ese branch o ese ramal de ese circuito, por ejemplo.
Entonces, como grupo, mirando el mapa, estamos pensando ahora en directrices para el negociado. Mirando ese mapa, haría sentido, porque una directriz del negociado puede ser utilidad. Usted tiene que presentar información de restricciones en los circuitos para que entonces desarrolladores como Luis puedan ofrecer soluciones que sean targeted solutions. O sea, eso haría sentido, o sea, presentar este tipo de información para que entonces, o sea, lo que se estará presentando son las restricciones a nivel del circuito que han sido identificadas, no de simulación, verdaderas, para que entonces soluciones de desarrolladores o terceras partes calificadas, pues sepan primero qué proponer y qué tipo de soluciones presentar.
Sí, yo creo que, ¿verdad?, eso permitiría la participación, ¿verdad?, del público, ¿verdad?, en el tipo de soluciones a problemas que nosotros podamos experimentar. Ciertamente, ¿verdad?, esto por lo menos da una idea general de las situaciones que experimentamos y posibles soluciones que puedan presentar entes externos. Obviamente, pues, los detalles, ¿verdad?, pues quizás ya la utilidad, como tiene más información, podría ir quizás más al detalle, pero ciertamente es una herramienta que podría dar pie a que tanto nosotros como en otras áreas de la empresa podamos ver otros puntos de vista para solucionar problemas, de forma que todos puedan participar en la presentación de soluciones a los problemas que estamos experimentando.
Sí, y aquí la diferencia es que nosotros nos estamos ahora enfocando en las restricciones a nivel de distribución. El plan integrado de recursos no mira a nivel de transmisión y generación. Nosotros nos estamos yendo a este nivel. Entonces, ¿cómo habilitamos? Porque en este momento no existe un vehículo para presentar las restricciones del sistema a partes calificadas para que puedan brindar soluciones. Eso puede ser un paso al cual se debería explorar y podría ser una directriz directa al operador de T&D.
Sí, ahora mismo nosotros, ¿verdad?, como hemos visto, ¿verdad?, en los talleres, nosotros ahora mismo en la autoridad, ¿verdad?, pues no contamos necesariamente, por ejemplo, con esta herramienta, ¿verdad?, hacer este tipo de análisis. Esto lo trabajamos en su momento con Siemens, ¿verdad? De nuevo, la data nosotros la tenemos, pero obviamente presentarlo de esta forma visual, pues quizás esa capacidad no la tenemos al momento, pero ciertamente nosotros
habría que identificar, ¿verdad?, las herramientas y los recursos necesarios para tener este tipo de visibilidad.
Sí, pero nosotros vemos que diferentes utilities, ¿verdad?, están haciendo análisis, como había mencionado Tom, de hosting capacity, ¿verdad? Otras utilities están trabajando con este tema y ya quizás pues lo han ido desarrollando. Sabemos que es algo que es relativamente nuevo, pero al final del camino nos parece a nosotros que eventualmente tanto nosotros como otros utilities vamos a estar trabajando con una herramienta como esta porque nos parece que nos ayuda en los análisis que realizamos y nos simplifica el tipo de trabajo que realizamos, por ejemplo, cuando analizamos sistemas o circuitos como el que tenemos aquí ahora mismo de frente.
Abundando en el tema, ¿verdad?, quería decir algo importante. Esta radiografía o este modelo que tiene el mediodía, nosotros cuando tenemos algún tipo de usuario o potencial prosumer, nos gustaría y nos hace falta ver este escenario en los momentos en que los determine la utilidad. Por ejemplo, si tú tienes un modelo de la hora pico y un modelo de la hora no pico, o a través de las 24 horas tienes 3 modelos o 4 modelos o 5 o 6 modelos, ahí uno puede trabajar con clientela que sea desarrollo porque es un comercio que trabaja diurno, que trabaja 5 días, que trabaja 5 días 2 turnos, que trabaja 7 días 3 turnos, porque nosotros tenemos que, ¿verdad?, proveerles un servicio a ellos completo. No puede haber un servicio que después haya que hacer ¿verdad?, un corte de producción. O sea que esto va a ser dinámico. O sea, hace falta, pero hace falta uno que pueda dar la alternativa correcta al candidato, a la ayuda. Esto también nos tira una información, ¿verdad?, que ha habido una concepción anterior, hace años atrás, no sé, hace 2 años atrás o 3 años atrás, que alguien mencionó en Puerto Rico que si a todos los techos le ponemos unas placas solares, podemos cambiar toda la energía de la isla a renovable. Y esto te lo demuestra que no es cierto, porque no, eso es falso. O sea, todo tiene que tener planificación, visibilidad y después una ejecución. O sea, y esa es la importancia que tiene este mapa para nosotros como desarrollo. Adelante, sí.
Nada, para estar bien clara, esta área es un área urbana, pero esta área, estamos hablando de Las Piedras, ¿esta área donde están las farmacéuticas?
Podría ser que hayan farmacéuticas por el área, pero
Ajá.
Las farmacéuticas del área de Las Piedras no se suplen de ese circuito.
Ah, ok.
Sí, porque las farmacéuticas se suplen a voltaje de 38,000 o 115,000 voltios.
Okay, perfecto.
En el caso de nosotros y el circuito que estamos viendo, pues a voltaje de distribución, y por lo menos no suple cargas industriales. Este tipo de circuito que tenemos de frente, ¿verdad? Lo que atiende primordialmente son clientes residenciales y algunos comercios. Y típicamente en esa área, pues sí hay comercio, ¿verdad? Las carreteras principales, pero la gran mayoría que está quizás más alejada en el circuito son clientes residenciales.
Okay, gracias.
Sí, seguro.
Esa área es rural, la comparte el compañero aquí en la computadora, es un área rural y puede que ese comportamiento sea porque ahí no hay carga. Puede ser. Pero para el punto de vista de lo de hosting, el modelo del hosting debe ser dinámico, debe ser predictivo para ustedes, porque por ejemplo, uno lo puede ver de manera de planificación y después poder someter una petición de esta área se ve mejor, esta área se ve no mejor, esta área no se ve bien para insertar y poder llegar a esa comunicación rápida para proveer, ¿verdad?, el desarrollo, porque eventualmente queremos que todas esas líneas estén en renovables de aquí a 30 años. Y entonces, pues eso puede identificar algunos pasos que haya que dar en el camino, infraestructura, para permitir que haya inserción completa.
Sí, yo creo que lo importante en todo este análisis es que, ¿verdad?, en el caso del utility, que este tipo de herramientas y análisis que se haga, ¿verdad?, no sea necesariamente, ¿verdad?, para identificar esos lugares donde pues es difícil de interconectar GDs y que el utility diga no, pues no se puede conectar más nadie allí. Yo creo que la mentalidad que tenemos que tener es, mira, tenemos una condición que estamos identificando, ¿qué opciones tenemos para solucionarla? Entonces, de esta forma, permitir no solamente la integración de sistemas que utilizan fuentes renovables de energía, ¿verdad?, que es lo que principalmente se está desarrollando en Puerto Rico, sino también, ¿verdad?, pues, el resto de los clientes que podamos tener, que son, ¿verdad?, más bien cargas. Así que me parece que con todos estos análisis, lo importante es buscar soluciones a los problemas que tenemos. Yo creo que ese es el fin que tiene la empresa. Cuando tiene un problema, buscarle una solución y no es decirle que no a los clientes. Yo creo que la intención y el fin de nosotros no puede ser decir no. La razón de esto es buscar qué problema tenemos, qué opciones tenemos para resolverlo y cuál de esas opciones es la que económicamente es más viable. Y entonces por ahí pues irnos moviendo. Va a haber algunos lugares que quizás es más fácil hacer estos cambios. Hay otros que, pues, ¿verdad?, por las limitaciones que tenga la empresa, pues puede ser más complicado. Pero al final del camino, me parece que la idea es que podamos incorporar tanto más carga a nuestra red como también más generación, ¿verdad? Y por eso es que debemos establecer, ¿verdad?, esta guía y este plan detallado, ¿verdad?, de hacia dónde debemos movernos, ¿verdad?, como país para lograr esto.
Una de ¿verdad? De los comportamientos de un mapa como este, que nos da la oportunidad de que la utilidad y también, ¿verdad? Tengan un plan corto plazo, un plan a mediano plazo y un plan a largo plazo, de dónde van a ser los incrementos, mejoras, modificaciones de manera planificada y presupuestada. O sea, también te da un mapa de trabajo con un plan.
¿Alguna otra pregunta?
Sí,
Sí.
yo diría que la alternativa sería ir educando al pueblo cómo hacer sus implementaciones en ese caso donde el utility no va a poder mejorar por la poca densidad poblacional, pues que ellos, el que quiera hacerlo, hacer un off the grid, un proyecto y se independicen completo. Y es una alternativa. O sea,
Buscar soluciones que sean más cercanas al cliente, claro que sí, sí, sí. Sí. Sí.
Is there like an ideal coordinated scenario that you would envision on a single circuit that myself developing one property, my neighbor who may or may not be developing another solar, and the other neighbor, how does, I mean, is there a coordinated effort to say, we're looking at this circuit, here's the information that you need, here's an RFP, and then have an opportunity for, you know, the electrical engineers that may be working on various projects and various developments to
Let me
then
throw it
come
really quick.
forth
Yeah.
with,
That's exactly what we're doing right here.
yeah.
We are trying to come up with planning directives to orderly enable exactly what you're saying.
So
If it
circuit
makes
number
sense,
2801,
right,
there's an RFP out.
right,
You have 30 days to request more information.
right.
That might even be one single page. I mean, is
So as a working group, as a group,
Mhm.
will that make sense to recommend to the prep
Yeah.
to enable that kind of approach for targeted solutions using this kind of information?
Mhm. And I'm paying 2 electrical engineers right now to like wait or do supplementary studies that may not go through. So like, how do I put them to work to, to get what you need on your desk for that coordinated effort? If you need 7 more engineers on your staff, then, I have 2, I know it's more
But it's a process. This is the paradigm shift in the industry. It's just not in Puerto Rico. Esto no pasa nada más en Puerto Rico.
true. It is
Estamos
true.
viendo que ahora desarrolladores, terceras partes, están poniendo servicios de utilidad en la red. Entonces, es un reto para ellos, porque entonces tiene que operacionalmente integrarte a ti y que haga sentido todo para que se quede confiable y seguro. Pero por eso que estamos aquí, porque estamos buscando el roadmap, la hoja de ruta, para que de una manera segura y confiable se pueda integrar esas facilidades para darle beneficio a la red pública. ¿Otra pregunta para el ingeniero Marín, por favor? Muchísimas gracias por su tiempo y en verdad que muchísimas gracias por compartir su conocimiento.
A la orden a todos, estamos disponibles para cualquier pregunta y siempre estamos, ¿verdad?, en pro de que haya una red resiliente, que haya un servicio eficaz para todos los consumidores. No tenemos, ¿verdad?, ninguna emoción en decir que se vayan off-grid o se queden conectados, porque realmente depende de muchos aspectos. Nos encontramos trabajando en unas reparaciones y en unos proyectos para la red grande. Pronto escucharán cosas por ahí por el ambiente y estamos a la orden. Estamos disponibles a través de la información de aquí del negociado y también en las redes.
Muchísimas gracias. So we're gonna
Camacho,
we're gonna have.
Camacho.
Ya, sí, por favor, claro.
Yo no entendí bien el caso de ella, de que se abre un
Déjame
RFP.
explicarlo.
¿Me
Sí,
explicas?
sí, déjame explicarlo. Y eso pasa en otras jurisdicciones. Hay directrices en otras jurisdicciones que le dicen a la utilidad, usted tiene que publicar las restricciones a nivel de circuito para que desarrolladores y terceras partes puedan insertarse en la conversación de soluciones, presentar soluciones a las restricciones que se publicaron. Entonces la utilidad haría un RFP para ese circuito en específico, con esa restricción en específico, para que entonces terceras partes puedan hacer sus propuestas. Entonces a nivel de distribución, no es a nivel de IRP, sería a nivel entonces de distribución eléctrica.
O sea, que ellos hagan la propuesta para mejorar el circuito.
Sí, bueno, el RFP viene de ustedes. Ustedes están identificando la restricción y le dan la información de la restricción y ellos entonces harían las propuestas de las soluciones. Y un buen punto, es un buen punto, Irán. En algunas jurisdicciones hasta ellos ayudan a la utilidad a hacer el requirement of el RFP.
¿Y el fondo, quién fondea aquí?
Depende de la jurisdicción. En algunos casos el RFP lo paga los clientes. Eso es una permutación. Hay otras permutaciones donde quizás hay un green bank, si es todo energía renovable. Depende de la jurisdicción, sí.
Mira este caso, ven acá.
Sí.
So you're handing off to me? Oh.
So really quick, Tommy is going to go ahead and continue his presentation. So any questions, you can go ahead and
And I'm going to inject something on that last conversation briefly. There is this question about budget in a utility, and this is an indication. So I'm just going to give you a quick, and Tomas, if you align with me on this. If you think about this type of solution and you're thinking about an RFP for a solution for a non-traditional DER solution, the utility already has a challenge. And the challenge is, how much investment money do I have to meet my peak load analysis every year? They've been doing that for the past umpteen years, lots of years. And every year they have to make decisions on what level of exceedance in their system they will fund to meet a need. And that is for peak load. And then now for a low load condition that is generated by DG, the question comes, why would I get into that situation? Your agenda needs to be not to get into that situation by targeting the locations first before you get in there. But if you do get into that situation, then you ought to be competing budgetary requirements between how much money you might spend on an overvoltage versus what you would normally have to spend on your system to do reliability and enforcements. So it's a competing priority of budget for the utility. I'm just highlighting the fact that there's nothing unusual about competing budgets for the utility and having a cut line on how many projects you can do a year. This just adds to the potential cut line. Your objective through our whole conversation and what this distribution planning is about is to not get in that situation, or at least to minimize the amount of potential cases where you're going to be over because it got past you. And so I would argue that's got to be the agenda, is try to be out in front of it. So I'm going to go into the two pieces here. I talked earlier this morning about the fact that I was going to talk about some of the data and the technical requirements, and then some of what are the things that you do to resolve and increase hosting capacity. And so that's what I'm going to do here. I'm going to try to streamline a bit in the conversation, but obviously I want to engage folks in the process. So first and foremost is there's a lot of requirements on how to calculate hosting capacity. And on this page, I'm trying to list the types of things that are necessary to do that. Measurement data at your substation and having a distribution SCADA environment that gives you adequate information over a period of time so that the engineers can properly develop a load scenario in the model. You need GIS mapping. We talked about that a lot this morning. Most utilities have targeted individual feeder analysis in this case. It's not unusual because a lot of the tools out there also look at individual feeder analysis in the distribution system. You need to look at peak conditions, you need to look at off-peak conditions, and you need to understand that voltage class is very dependent in the host capacity analysis. So when you're thinking about this, your load forecasting is very important. As I said earlier today, your peak condition is typically done every year as part of the utility process anyway. So you should have a reasonably good understanding. The off-peak or the low-load condition is typically not done. So that's a new process that has to be part of the equation. The modeling capabilities and the scale of the model is important. We'll talk more about that. Grid edge measurements, they are less known. They are less known for all utilities. So, you know, and I'll talk a little bit. In this case, your grid measurement at the substation means that you're probably a half a mile to 10 miles away from where the customer is at your last measured condition that gives you some kind of frequency of measurement, 15-minute, 1 hour, not a monthly kilowatt-hour reading off a meter. Your system-wide models are not available typically. Oftentimes, there are models done on the fly when I need to do a study, and not all models are run every year. So as utilities advance their cases, they are running all models every year, and that is a best in class, and would be doing that for individual cases. The aggregation of capacity does change at the substation level. So if you think about hosting capacity, if you say there's hosting capacity on 5 circuits out of a substation, you can't add them up and say that's my hosting capacity at the substation, because it's a different measurement. So it's important to understand that you can't look at adjacent feeders and think about adding one large installation and not recognize that the substation may be a limiting factor. The connected and queued DER is very important, and we talked about that earlier. PJ talked about that. Understanding it and making it transparent. One thing is identifying it, and the other is making sure it's included in your model analysis. That's a little bit more difficult because most utilities are still in the process of their back-end systems linking in the project application process to the GIS update process. And that's a challenge. Some utilities are still manually doing those types of updates. So if you think about automating a hosted capacity process, if you're manually updating your GIS from that, your timeline to do hosted capacity is going to be very difficult to bring down. It needs to be automated. You need to find, and then there needs to be a process to do that. Voltage regulation is important, and feeder reconfiguration, and we're going to talk more about that. So I want to just...
Can I ask a quick question?
Sure.
Back one slide. So just a little curious on that third bullet, the individual feeder analysis. What would be included in individual feeder analysis that is not part of all of the other bullets? So like when I think of individual feeder analysis, I would be thinking about some of the SCADA and the peak and off-peak and the grid edge and the voltage regulation. What are the devices?
Yeah,
on there? So
what I'm trying to say is that most utilities have presented their information with an analysis done at the feeder level. All of the other components identify how the quality of the analysis at the feeder level.
Okay, so it's more like that is the synthesis of all the other data points to come up with a map of the individual feeder like we saw in the previous slide.
At this point, with GIS systems and feeder level, it seems to be a natural norm that showing them and the street lines aligns between stakeholder value and what utilities have.
Okay, cool, thanks.
Yeah. So I'm going to go into a little bit more detail on these. So load and DR forecasting. We talked a lot about the fact of how important it is in the distribution planning process, and it will be a lot of the discussion that will take place in the planning session 2 weeks from now. This is extremely important in the hosted capacity analysis. And so Tomas talked a little bit earlier about essentially using the Sandia screens at 15% of peak as a trigger level for studies. If you had better load data and you understood your load profile a lot better, you would not have to use that screen. You could use a higher value and have a much higher hosted capacity. Other utilities that have a lot of SCADA beyond the substation, as well as within the substation on all phases, can increase their tolerance on that screen and change the screen from 15% and potentially use 26, 28, 32%, that type of range. And that increases hosting capacity because you have enough information in your model to understand the analysis better. So that's an important part. So The load forecasting and the granularity and understanding of that forecasting changes hosting capacity. Because if you don't have the data, you have to be more conservative in your assumptions. And Maria's not here, but this would also be extremely important with dynamic hosting capacity, because the more you know about the load cycles and the hourly rates, the better potential you have for feeding it into some kind of ADMS platform and understanding its change in time. So I'm being very simplistic with the next set of slides because some folks were asking, and I'm kind of doing a little bit what the utility would do, but I'm going to tell you what I think exists on a lot of this in a simple way, and then talk about how to think about the evolution of it.
Could I interrupt with a quick question before
Sure,
you go into
BJ.
the next set of slides? What you just said on this slide is fascinating to me. And I've heard this elsewhere too. So 15% is a number you have to use right now, so we don't have all the data we need to do a more sophisticated analysis. But if we did have that data, maybe it would be 26, 28, 32%. There's only 2 nodes that are at capacity right now, right, of the 1,300. And we don't know how many other ones are close to it. But what is the fastest track scenario that we could have the data we need to use a higher number? Are we talking about something that's definitely going to take years of study to get there, or is there some way to fast track that if needed? For example, on those 2 nodes that are already full.
So I won't, Tomas, maybe you could talk about the solution. I can align with you.
Yeah, based on what he's talking, as he said, if we could have more data for our feeders, maybe that rule of thumb that we have been using, that other utilities are using, could be changed. But with the infrastructure that we have right now and the field data that we have, it's hard to try to set the different values for feeders right now. But as we move forward, if we implement more metering equipment and we gather more information of the system, that's going to give us a better idea if for a particular circuit, supplemental study is needed or not. As of right now, you have to comply with certain requirements, and one of them is the 15% rule. But that's something that I think, as Tom was saying, in the future, if we have more data and we take a better grasp of the feeders that we have, we could eventually come up with different kind of criteria to require a supplemental study.
Would that need to be global across the utility, or could there be something done short term at those 2 feeders that are full already? Is there some gizmo you can put on to start measuring the data?
Yeah, for the feeder that you're talking about, I think you're talking with the 2 feeders that as of right now, PREPA has 2 feeders where we have limited the additional integration of PV systems because we have made simulations and we have found voltage regulation issues on them. As with the infrastructure that we have right now, it's difficult to include additional PV systems to them, and that's why we could not responsibly, as of right now, recommend additional PV systems. But solutions have to be come up at some point in order for us to be able to manage better the voltages that we are currently experiencing over there, in order to allow additional customers to install DG systems.
So I'm going to talk about this a bit.
Okay.
And it'll help the situation because I think it'll answer some of the questions, or at least propose some of the possibilities.
And can I ask a quick question for the developers? So to the degree that you would be relying on the hosting capacity maps with color coding in the green, orange, red, yellow, what % accuracy would you want, and what % accuracy could you live with?
For example, if we are looking for a project to go in,
Yeah.
we are looking for a way to interconnect the project.
Yeah.
Actually, the utility is the one that has to set the standards in accordance with the Bureau and just say what is going to be the scenario on how things are going to be allowed to get interconnected.
Well, I guess the nature of my question is, ideally, the map would be 100% perfect, and it would give perfect clarity about what's red, what's orange, what's yellow, and the corresponding costs. But from my work with utilities, PREPA included to a degree, there's an engineering mindset and a desire to try and to get that as close as possible to be 100% perfect for you guys. But on the flip side, 100% perfect comes with a lot of costs of getting data, comes with a lot of time to try to cleanse that data. So I'm curious, could you deal with 95? Could you deal with 90? That's what I'm just trying to. Sorry, I'm just trying to.
Let me set an example. Yes.
Yeah.
So if we are looking at a horizon of 100% integration of renewables, so if we are looking for that, what we need to know is where we can interconnect and the level of granularity you mentioned, right? It could start with the two fronts of attack, maybe intelligent meters at the bottom and some SCADA incrementation from the top. So it could be a dynamic development of information, but for the economic and the commercial and the sales part of this, the economics, we need to be able to know if we can integrate. For example, he's making a case of two difficulties or two spaces that have an opportunity, and he wants to know what can be done. And I think what needs to be done is prioritize those areas and just have a better answer right now, and then increment as the game allows the speed of the information to grow and the level of granularity.
Can I interject one item on that? Because I would turn that question around. I don't think that is the right question in my mind, and here's the reason why. The risk of the percentage is with the utility. The risk is not with the developer. It's with the utility. Saying it's the developer. I know, but you're asking what they would accept. And I think the real question needs to be, what risk in percentage error is the utility willing to accept to allow the developer to connect? And then I think that is a reasonable question from a standpoint of understanding that the utility has the obligation to correct problems that get created, and that obligation is, in a rate case, paid by ratepayers. So that's why I bring it up that way. I think everything is an estimate. There is no 100%. It's going to be something less than that because it's a model to begin with. It's always going to be wrong.
I guess I'm looking at it from a perspective where if the utility is trying, right now there's no hosting capacity. So you don't have anything, and it's highly manual, right? And I'm thinking of steps towards an end state, right? So if it's something that we're looking at it, right now from let's get the best data possible as an end state kind of thing. It's like, okay, but it's going to take us 5 years to be able to get that for you guys. If it was something you're saying, if we could get 75% or we could be comfortable with 75% just to get us a map, and we could do that in a year instead of 5 years. I'm just trying to find, is there a please?
Question. Yeah, I think I understand the question, and I think that the answer from the developer's perspective is, right now we do know that there's hosting capacity in all but 2 nodes. 2 have been studied to the point where you're at the 15% threshold. We assume that there's some in the rest of them. I think from a development perspective, it would be the most helpful if we could have a high-level analysis that says, you know what, we know we have at least space for at least 3 megawatts in this node and 7 megawatts in this node, maybe more, but we know you can go ahead and apply up to this certain level, and then it's a race to see how quickly you can get to that point of maybe saturation, and then to get over that hump, so enough security, I think, that you could just publish that map and say, okay, we got space for 20 more houses in this neighborhood. and then you got to trigger the supplemental study thing or whatever.
I personally think that there's always a wishful thinking, but as you mentioned, reality, we need to get real and practical. And as also has been said, like there's no visibility right now. So anything that is better that the current set is something for me that is like, okay, I'll take it because it's better than the status quo.
Yeah. And you're right, because I alluded to it before, but that's what other jurisdictions have done. They've taken those steps, so we're building up to that. We're trying to say, is there an alignment that makes sense?
Yes, but something that I was gonna say before lunch break, but I'll address it that for future or whatever. Like I try to think about integrated. And yesterday was resiliency, critical projects. I think that a pass through can be places that has been defined as critical projects or critical places to start up, because I think that those are the areas that will have the first priority, or for example, orphans or to start identifying the places is something that for me is very important to identify and to have and start prioritizing. But definitely is something that will help us your first slide, the low cost analysis that can start giving. So because right now the most of the financial constraint and everything is inefficiency and ineffectiveness, because it's not accurate in some kind of way, and maybe the utilities losing their time, we're losing our time with something that is not feasible. So for me as a developer, any information it will be helpful, and I know that the guys are on prep on the utility are working on it.
And listen, that's a good point in regards to the location. I mean, if we are going to do phased-in, it's a phased-in progressive approach. Is it going to be a function of the location? So the guys that come from DOE, one thing that we did in Puerto Rico some decades ago was that we truly electrified this island. What that means is that you could have somebody all the way up in the mountain, 1 or 2 houses, and they send a feeder all the way up there to actually electrify that house. What that means is that you may have low density. You may have feeders that go across the island with low density. Does it make sense to start characterizing those areas of low density? Or like Carlos is saying, are we going to prioritize as a function of critical facilities? Now, we have to be careful, right? Because we are building a system that has to be reliable for everybody. It's not that we're going to be selecting and choosing. This is the area where we're going to actually add resilience. So we need to be careful into how it is that we're going to prioritize, but the location approach is one that we need to explore as a group.
I believe right now the integration could be like a rough code capacity. If there's a demand to interconnect, we should help them solve that initial wave of requests, and then at the same time be developing this plan of the locations. And I think we should divide and conquer. This should be done on spreads around the island, not only on the only one solution of, it should be done in multiple attacks. We should be attacked by multiple fronts.
Yeah, that has to be part of the equation, because the commission needs to understand an umbrella solution. It's got to take all of the issues into consideration, because there are cost comparisons, there are cost-benefit analysis. There has to be some give and take on where money gets spent and its value that it provides, and while you're moving forward as much as you can.
I think that one way to prioritize looking around and saying, okay, which ones should we start off on, I think is just this really basic data, is whatever level it already exists, the data for, okay, we have 15 gigawatts of solar that we know for sure is interconnected, and we know where it is. We know what region, we know what circuit. So the circuits that don't have any, we're probably not the ones to prioritize. The ones that have an increasing amount of solar coming up on them, let's prioritize those first.
Right. So these are important items, and we need to talk about it, because I think that is where we're going to get to. What does that roadmap look like? We're still doing the building blocks of a piece of this, so I'm just going to continue on for that. This is a very basic representation of the system. Early this morning, there were some conversations about what system exists. In Puerto Rico, the majority of stations have one transformer and 4 or 5 feeders, circuits that emanate from it. All of the customers are supplied either residential, commercial, industrial, off of those feeder lines, and there are not in many cases any ties between those lines. And as Tomas was talking about, in the substation, on one of 3 phases, they may have monitoring and control of that breaker. So at a point in time, they understand what's happening here, and that circuit can be very long. And that's, and I'll talk a little bit about what that, but that's a typical configuration. And guess what? Not an unusual situation in many other utilities in the U.S. Some have advancements, and I'm going to talk a little bit about what those advancements look like.
Tom, just for a quick question, how do you define, or what is the definition of a feeder?
So a feeder, a distribution feeder, is a feeder that emanates from a substation that has a breaker, and the breaker is a protection device that isolates a line out to a point of a customer. So, and that could be half a mile, it could be 10 miles.
So just for the record, it's just the feeder is just not, it also takes the line. It will be as part of the element of the definition.
A feeder is the full line that goes out from the station that is fully connected with all closed switches. And usually the utility will say, that's my feeder's normal condition. So it's design condition. And then they operate the system because things are happening, and there may be times when they have to change that configuration. Sometimes the changes are temporary, and sometimes they're permanent. If they're permanent, the feeder has to be changed in the model, in the GIS, and then restated as this is feeder 1, 2, 3. So that is typically how any distribution company will talk about a distribution feeder circuit. And they have different configurations. I'm going to talk a little bit about that. And this is very basic stuff, but I think it's important as we think about hosting capacity. There are some stations that have 2 transformers in the station, so they're optimizing the property. These might be in urban areas that you would find more dense loads, and you need higher capacity. In those cases, they would still have 4 or 5 feeders per transformer. I'm not showing them here, and they would spread out. In some cases, they would actually be used a little differently, and I'm going to talk about that. But this is where you have denser areas. You're not going to find this in the mountains. In the mountains, it's all going to be 1 transformer. And I don't want to talk for the PREPA team. I'm giving you norms and my understanding of how they fit, because this is the same as any other utility out there. They all have similar configurations. When they have more dense loads, they will optimize the real estate of their site and try to put 2 transformers in there and have feeder circuits go from that location. Now, along the lines, and you asked about a feeder circuit. So here's an example of some items related to what is a feeder circuit. Along the feeder, it could be from a half a mile long and less to 10 plus miles in length. So these feeder circuits can be very long. The higher the voltages, sometimes it's easier to carry the distance. You can control the voltage better. The lower voltage circuits, the 4.16 circuits, voltage control is very difficult when you get to 10 miles. And there's a lot of different things you need to do on the circuit to control the voltage. I've only listed 3 feeder levels here. Tomas talked about 5. There are 4 kV, and then there's a 4.7. Those are older. And then there's the 8 kV and an 8.4 or 8.6.
Yeah, we also have 7.2.
7.2.
And 4.8.
Right.
Yeah.
So these And,
Yeah.
and by the way, once again, I'm not at all surprised by that. Lots of utilities have systems where you're capitalizing equipment and it's working, and they have programs to slowly upgrade them. And so you have 4 kV, that's 50% of your feeder circuits today. There's a utility in New York that has the same thing and doesn't have monitoring at their substation. So it's not that different than a lot of other areas is the point. Important here, there are hundreds of nodes that might represent this one circuit. So it's not a node. This is hundreds of nodes, and along there are going to be customers, and this is a very simplistic view. But what I'm showing here also is that there's a thicker line the closer you are to the station, and there's a thinner line as you go out. What that represents is that as utilities historically, the closer you were to the station, all of the load that's supplied the customers on the whole feeder has to go through the front end right out of the substation. And as you get further away and some customers have already been supplied, the amount of load and amps necessary beyond that is less, and so the utilities didn't always install the size cabling as you went further out on the feeder. This becomes a limitation when you put a generator on the outside. So now you would have a constraint. Many utilities have changed their system over years to have a new standard for construction that if you're on the main run, the main 3-phase run of a feeder, that even if you're well away from the station, you will install the size cabling you would have near the station, so that you are adding the capability of transfer capabilities over time. So it's there for load, and guess what? It's also there in benefiting DG, if you're doing that. So design standards are important in evolution of the utility planning here. Most utilities, though, have smaller cable as you get further away from the station. All of points along there's going to be cable, and then there are going to be poles and underground structures. The model that folks talk about will usually be cable points between poles. Each pole might be its own data point, and the cable between them is a segment of that data point. These are important because when you do modeling and hosted capacity, this is the granularity that you might be able to present graphically.
Something I've heard, please correct me if I'm wrong. I agree with everything you've said, 100%. Just to bring a little color commentary to this collection of the circuit capacity and the devices, it's my understanding that after Maria, FEMA had waived some of the requirements for like replacements. So even though that thickness of line and some of those intermediate devices may be how it was designed and how it may be represented in the GIS, it is entirely possible in the field that in order to get the lights back on, different types of line, different devices may have been used that are not up to standard that could have drastically different actual hosting capacity as opposed to the records that exist. So just as a consider, or please feel free to.
Yeah, after Maria, I don't know, I don't have all the information, right? But I'm pretty sure that there could have been situations where to give service to certain customers, probably the conductors that were used, for example, maybe some conductors were cut because after the hurricane the pole went down and the conductor broke. It's possible that in some situations the reconstruction process required in order to give service that maybe the conductors used were not with the same ampacity that it was before. Probably some loads now are being supplied from a different transformer, or maybe more loads were connected to a particular transformer to supply that load. That's something that I'm pretty sure happened, and probably those changes don't necessarily are included into our GIS database.
And this is why I was asking the question previously of like 75 or 80%, right? That you could go with the data you have, but it may not reflect the reality of what's actually in the field from the post-construction, that in order to try and get a hosting capacity faster to the developers, you could go with what you have, but it might not necessarily reflect reality. So that's
Great.
the context.
Totally aligned with everything you guys have said. And, you know, it is and once again, I'm going to say, it might sound like a broken record, but every utility that is in a storm area deals with exactly the same thing. Not exacerbated as much as Maria, but I've worked storm response in many utilities. And it is the due diligence of the utility and the timing on their ability to make sure that you don't change their system or that you use adequate equipment. And that means you have to have it in stock. You have to have adequate quantities, and clearly that was not the case for Maria with the type of damage. So you have a lot more potential for trouble. But every utility has this as a problem and has to work through it and to make sure that they clean up at the back end, which is not just get it up and running, it's also what changed in my model. And then sometimes 6 or 8 months later, you're finding a problem. It burnt down because somebody used a smaller piece of wire to get something back up, connecting 2 larger pieces of wire, and it became an equivalent of a fuse. So very common, and this is a good question of saying what is good enough. And I think there's some examples of what that looks like. I want to show here also on the feeder circuit simplicity. Off of the main run, and we call that the main run, there are these legs or spurs, they're called, on a feeder circuit. They could run for a long distance. They usually have fuses that are on the end that connects off of what is usually the main run of the feeder. And they are more often than not, the feeder run itself is usually 3 phases, A, B, and C phases, balanced system. And when you run 3 phases together and you have customers, the utility has a much better chance of balancing the loads because they can swap them along the line because all 3 phases are there. When you connect a spur and you only put 1 phase, 1 piece of cable versus 3 pieces of cable, or 2 pieces of cable, that means that those phases are going to have more load. So the utility has to manage back along the run here to make sure that the loads at the station are somewhat balanced. And most utilities try to keep that within 10%. If you're only monitoring 1 phase at the station, then you really don't have a good understanding. Are you within those normal tolerances of 10%? I don't know if 10% is what you would use, but that's what I have seen as norms in planning.
At least from data we have gathered at feeder heads, I think we've had feeders with 20%, right? De balance. We've seen feeders data with over 20% on balance. So yeah.
And if you don't have the monitoring on the individual phases, you don't have the indicators to tell you, I need to work on that.
That's right.
And because it might be as simple as taking this 1 phase leg here and swapping it to another phase and bringing it from 20% to 12%. And 12% might be reasonable. But folks might target 10%, and then, of course, they're trying to keep it within that. They will go out of range in time when new loads get added or after a storm when this phase is changed. And so inspection after storms are very common to try to correct and fix.
So on that one really quick, Tom, to get the current state of the system, is it common practice for PREPA to fuse these spurs, these laterals?
Yeah.
They're fused? Okay.
Yeah, it's very common, but PREPA does is when we have, branches supplying, particular areas, we install fuses, and in case that a fault occurs in that branch, then you would lose that area and not the whole feeder, for example.
Right.
Instead of opening the breaker at the feeder head, if a fault occurs down that branch and there's a fuse and it's a permanent fault, then the fuse would operate and that area would be without service. But then again, you would not lose the whole circuit. We do have fuses in branches all along the island. Yeah.
And that's very common, and all of the design tools help with fuse coordination normally within models. So it's a very common. I'm not giving you that level of detail here. I'm just trying to give a perspective because these are components that impact hosting capacity. So the other case is how could you get better reliability? What level of complexity do you get an increase in? And so I think Tomas alluded to the fact that there are some 14 or so circuits that have alternate configurations, that have backup configurations. And this is a case of the type of configuration. Many utilities have tried to do a lot more of this type of configuration because what they're trying to do is that the blue circuit is that feeder that comes out, and this would be an open switch and an open switch when blue meets green under a normal condition. But the two feeders are on both sides of the open switch. If you lose the feed to a transformer or you have a failure along, they have a automatic or a sensing switching scheme to reduce the amount of customers that are impacted. So if they lose the line feed to transformer number 1 in the blue substation, this breaker will open and clear the bus within the transformer. These switches sense that there is loss of power on one side, and they close in and they restore the customers on both sides. Those types of configurations are advanced configurations. They require switching. These switches cannot be manual to do that. If they're manual, then you have people driving and they are doing it, and that happens more often than not, but you're in a 2-hour event for an outage on that. This type of configuration is an advanced configuration with control capabilities and might be back in 10 to 15 seconds. And so, and that is upon the loss of some supply into this transformer. And that's not an unusual occurrence. Those are types of occurrences that most utilities will design for. So there are advancements around this, and this requires, as some of the discussion talked about with the grid mod, capabilities to put switches, automatic switches in the field along the feeder circuit. Now, what do you get from that? Not only do you get the reliability impact for customers, that they're not experiencing as many outages or the length of outages, you're also, when you put these switches in, you're getting readings. You want to be able to read voltage and current at these and have radio or fiber communication back to a database. So if you are aligning, doing that type of work, you're starting to gather the data. PJ, you asked the question, what data do you need? This is it. This is the type of stuff. If you advanced the data in the substation and got 3 phases and did it every 15 seconds, and then had a database analysis to manage that, and then you put these switches out halfway along the circuits, you would have a tremendous amount of data, and you would get yourself much closer to the customers with how much you know the load is. So the disaggregation of where the load is to the customers in the model will be much better. So this is what utilities have been trying to do and move down the line. Get some of these tools, make their models better, and then get the output value. And the value is in many fashions. It's the planning for peak load analysis, that is their core business environment. It's the additive value for hosting capacity to better understand where items are and to present that information. And it's also the value to be able to resolve some of the problems that Luis talked about earlier that might get created and come up with a potential solution. So that's one area, and I wanted to allude to that, where you can get closer to customers. Then, as Hiram brought up earlier, AMI is another area that can really change the load capabilities within your model. Because along these feeder circuits, there are lots of customers that have meters today. And most of those meters are kilowatt-hour meters. They don't measure demand in time. There are some, obviously, for larger customers that do. I'm alluding to the majority along some of these circuits. If you were to install AMI, and the business case for AMI has many components to it, one of the added values of that is understanding where the loads are on your feeder circuits so that the models that represent what's happening on the system, the error rate is going to go down. You're going to have much better information about where the loads are. Now, you have to couple that with cleaning up the data about which customers are connected to what transformers are connected to what phase, and what phase is connected to what feeder. But all of those components play a role in that. So there are a lot of tools that can help the model being better and the quality of data presented externally to the utility being more reasonable and having less risk for all involved utilizing it in different business cases.
I just want to, I have a question in regards to, since the beginning we have talked about the utility and the data. From the developer standpoint, what should be the information or characteristic or requirement that the engineers or people from the developers need to have in order to understand the data that they might provide or the hosting capacity? How because we're talking about lower the risk, but how the developer can use accurate data, how can it make an accurate use of that data? What kind of training? Because they can put the data on the modeling, but how we make sure that the person is understanding what they are uploading? Because that's a concern. Beside the color.
I totally agree, and I think it's an active part of this working group type environment to understand that if you're going to suggest to the commission that a roadmap should look something like this, part of that needs to be understanding and laying out the assumptions and how to communicate those assumptions if somebody is going to create a portal and put maps out, that there are tools and maybe video explanation of what the data means. Other utilities, if you go onto some of their sites that have done this, you may see a 5-minute video explaining some of the data on the map. Most utilities will have working sessions with developers, whether they're webcasts or in person, and they will talk about how they created the maps. No two utilities are going to be equal in how it gets done. They may do it very similar, but it depends on what data they have to work with. And so they need to explain some of the data assumptions so that the developer has a better understanding of how to use it. So that communication is critical in this process. And I've lived through it, and I've done it in facilitation, and it's so important because the lack of understanding impacts. This is a financial decision. You need to understand the value at the financial decision. So, and typically this type of configuration is done earlier in urban areas where there's higher sensitivity to low density, the number of customers impacted by an event. So it's not unusual for cities to have much more diversity in their feeder switching than rural areas, only because the impact of the number and scale of customers is dramatically different.
Just one other quick question, if I could. Sorry.
Sure.
So I really like the buildup of how this comes. And I guess in the discussion of the opening and the closing of switches, theoretically, if you took it to the next logical step and you were to open the switches, the blue switch next to the substation and the 2 green switches next to the green substation, then in the middle you theoretically have a microgrid that could be sustained and supported from some of the DERs and capabilities. I'm just curious, in the course of some of the other hosting capacity elements that you've seen, have you seen a different flavor, a different layer of a hosting capacity that has a focus on prioritized areas for microgrids or other elements about that tied into the resilience play?
I don't think I've seen targeted areas of hosting capacity for microgrids. I've seen various heat maps that have been generated because data sources have been very different in different areas. And so the heat maps were less granular when the data wasn't available. I've seen more of that. If you isolate this area and want to say that you potentially could do I'll call a community microgrid, I think it's called something different. I'm sorry, somebody might know what it's called in Puerto Rico. There's discussion around it, but it's a whole lot more complicated than isolating and putting a generator up, because you will see an outage usually, and then to put it back, you need to have very different relaying than exists at all of these switches to be able to restore it without taking the customers out again. So microgrids 10 times more complex than this conversation, so I don't want to go too far into that, but it's very complicated. So just want to talk, here's an example of reality. I gave you a one line, and this is even not as complex, but the feeder circuit emanates and it's all over. And you have different phasing. And this is generated from a real model. And so that's the type of importance that you have. Every little notch in here is a different node. So as I said, there are hundreds of nodes when you talk about distribution feeder. There are thousands of nodes when you talk about transmission. So the complexity of the model is much harder to manage for the utility on the distribution system. Now this gets messy, but it's good information to have. A lot of discussion, sorry.
Just one question, if you can go back to the previous slide. So we've talked a little bit about GIS today, and in the breakout sessions and in the discussion here, it's been noted that much of the current GIS data is inaccurate, has not been updated post Maria, and I'm seeing it as sort of a foundational element for hosting capacity analysis. I'm wondering if it's sort of an unavoidable requirement, a necessity, or if there are ways to work around that in thinking about what could be executed in the near term before like a whole GIS overhaul could take place.
So I think, as Andrew had noted, there are ways to think about it. What is the area you're willing to accept? And the existing models might be okay for that high-level view of what localized area might be an interesting place to look at real estate to put photovoltaic systems. But what you will find is that no matter what you do, you're going to have to do some work on the feeder circuit. If the model doesn't, and the technical term is converge, then you're not going to get results. So somebody at least has to make sure that there's a connection along the model. Not just that I can see it on a GIS map, but in the model it's not connected. So there are corrections that will be required even if you were trying to use the existing data as it is today. But every utility has the same problem trying to do that to generate host capacity. The more important piece to that is that if you do work on stepping that up from, if there is a current view of around 65% acceptance of it or belief, if you do some work to do that, there are many areas of gain beyond hosting capacity. So I think that the mutual gain is an important part of the equation in the conversation with the working groups in planning, with the commission about this feeds into your outage management system that every day is making decisions about what circuits, what went out and how many customers went out when an event occurred. All of the planning that gets done for peak load analysis is all part of that. The amount of load that you have on your assets and their asset life, there are reliability indices that are usually tied to that, are all tied to the load experienced in it. So the value is in multiple areas. So I think collectively agreeing on that and sharing that information and trying to understand the gap of financial cost and what's acceptable and coming up with some assumptions are probably a very good working area.
Part of Act 17, us as a group, to be thinking about how to implement. So Act 17 indicates that we need to maximize the use of federal funding. Maybe there's a way that we could think as a group how a GIS update could piggyback into the required baseline that the system needs. So somehow, if we can think about those two efforts, that they're not mutually exclusive, I think that may be a way to put a narrative that efficiency-wise, it makes sense to first do the baseline of the system and piggyback some kind of GIS update effort.
I'd also just add in, of the various, I agree everything. One other thing for benefits for that data, if you were to have an ADMS voltage regulators, capacitor banks, load tap changers, which PREPA already has, is my understanding, in the transformers in the substation. They just happen to not be monitored and controlled. And as a result, I believe there's a consistently high overvoltage as a means of operating the network. So if you were to have ADMS and have a better understanding for your GIS data cleanup and having a correct understanding of the impedance, you could better have energy efficiencies, energy savings for all customers by better managing the voltages.
Yeah, and the grid mod plan and the IT data plan that Hiram has talked about does talk about an ADMS platform, and I can say that there are lots of utilities trying to advance their existing modeling environments to put an advanced distribution management system in, and in all cases they have to do data cleanup, because if you're going to try to use it for more control capabilities, you're going to find a lot of different things than you found when you used it for some items that weren't as sensitive. So it's not unusual to say that data cleanup is necessary. It just depends on the scope. And I think what Andrew was pointing out, I'll point out to the team here, the only control on voltage that occurs at the substation. This is called a load tap changer in the substation. It's usually set at a value and it will follow a curve. But if you're a half a mile, 10 miles out, there's nothing along the line, for the most part, that's changing that voltage. And I'm going to talk a little bit about what that means.
Sorry if I keep getting ahead of you.
Does that help? Perfect. Okay, let me go there first, and then I'll go to the other slide. So we talked a little bit earlier about voltage tolerance, and Luis talked about what occurred when Siemens did a study. So the utilities are dealing with making sure they adhere to standards, and the standards around voltage for customers are ANSI standards, and they have limits, usually plus and minus 5% for normal operation. And then there are range B limits that exceed that for unusual conditions. But for the most part, the design criteria for the utility has to maintain within that tolerance level. So what happens is, under normal conditions on the feeder circuits that we just saw, that go from a substation all the way out, the voltage starts at a higher level. That might be, I'll say it's 126 volts, and it would just drop down, and it would have to stay above 114 volts.
14, yeah.
Right? And so, but along the way of the feeder, the voltage is always dropping, because historically the utilities have not had assets out on the feeder that are injecting generation. Now, there are cases where the utilities have tools to help to manage the voltage, but in this case, the majority of those tools don't exist in Puerto Rico. The control of the voltage is happening at the station and usually not along the run of the circuit. And so what happens is, if you put it
just one comment. In the 4.16 kV feeders, in most of them, PREPA at least has a voltage regulator at some point in the feeder. We don't have a virtual connection to that equipment. It doesn't have any kind of communications to the dispatch center, but for the 4.16 kV feeders, we do have voltage regulators.
You do have some.
And also fixed capacitor banks.
Right. And there aren't that many, though, right? And maybe I'm wrong. So if that's
voltage regulators, in the 4.16 kV system, yeah, we have a lot.
Okay.
But for the other voltages, no.
And so what Tomas is saying is, if you go away from the circuit, away from the station, As the voltage starts to drop, they've picked a point on the circuit based upon design or impedance that the voltage is brought up, and then it starts going down again. So you've increased the bottom level that the voltage would go to.
Correct.
So they're deciding where along the circuit to put that regulator to try to keep it from hitting this ANSI limit. And so the tolerance question that comes up with PV is when you put PV toward the end of a feeder and the wire is small and the PV collectively can be somewhat larger, what ends up happening is it raises the voltage and can go beyond the top level of the limit. Thus, customers are experiencing voltages beyond standards that they're supposed to be. So the utility is an obligation to do that. And so that's a key item, because that's the item that Luis was talking about that Siemens presented, where they said real time, that's occurring on this feeder in this location. And so what does that mean? That means that customers could be experiencing damage to their equipment if it goes beyond a certain level. That's why the utility works hard to maintain that tolerance level. So it's something that is important in the process, and you don't want to get to that situation where it's actually occurred. You want to mitigate it in advance, and that's why the application process and understanding hosting capacity is so important, because you're playing catch up if you're trying to fix something that got created because we didn't catch it while it was occurring.
Let me try to throw in the following technical question. So, to be within limits, is that going to increase the resilience of the system? And then, is to be within limits to comply with standards? I'm just trying to see how it is that you will put it in the narrative. I need to be within the limits to comply with this specific standard.
So there's a couple of aspects. I think I would argue that the comply to standard is the predominant answer, but it's important to comply to standard so a customer's equipment doesn't get damaged.
Yeah, I
right?
agree. But you hear the narrative.
Right?
You heard that you need to comply with national codes. You need to comply with national standards.
Those standards exist because there are norms about how equipment is manufactured and the tolerances of that equipment. That's why the utility tolerance operates within that range.
So let me bring it to the context of Act 17. You need to comply with the latest national standards. You need to comply with safety standards. So if this is a national standard that the utility needs to comply with, so what it is required to stay within those voltage limits. And I think there could be an argument could be made that in order to meet that standard, right? So we're building the grid back to national standards. So we need to comply with that.
And if you go back to the prior slide, the question becomes the utility systems have many tools to do voltage and VAR control on their systems. There are many tools out there, utility tools as well as new customer-sided tools. So utility tools exist where they are in fact changing and changing voltage and VAR flow here, and here along the way. And in doing so, they are reducing the amount of losses on the circuit, so they're being environmentally conscious. They're reducing the amount of generation required on the system because they're not operating your system in an over voltage manner. So there are many gains for doing voltage and VAR control in your system. One of them just happens to be hosting capacity. You definitely get gains by doing it for other reasons as well as hosting capacities. There's mutual gain, but it takes money to do it, and then you need to do good modeling to decide where to do it, where to put the devices to optimize the system. I don't know if I caught your answer, Chris.
Well, so that was basically what I was going to bring up, is that the ability to do volt VAR management either at the substation or provided from the customer and allowing the system to be operated at a lower voltage, I think would be a resilience benefit, because now you don't have to push a whole bunch of extra voltage onto the system to create either the enhanced reliability or enhanced resilience. You can manage that across various points across the feeder from the substation on down. And so I think there is a resilience argument for something like a volt VAR management, or better voltage management across the line.
Right. And if you do that, and you're actually resource capacity requirements.
Oh,
can
hang on
be
a second,
reduced.
Chris. That wasn't captured on the microphone. Please repeat that because this is being recorded.
Oh, I thought it wasn't.
Was it green? Oh, okay. I'm so sorry. You just
I think he was, yeah. But I'm just adding to Chris's comment that, you know, if you really do very good volt VAR management, most utilities are making a business case out of this by showing significant reductions in kilowatt hour requirements. And that is a direct impact in your resource capacity and the fuel requirements that are needed. So there's a business case for it, and there's an added value for hosting capacity on the grid edge the closer you do the voltage control to the customer. Now, I'm going to go back to this, and I'm not going to spend too much time because I'm only going to talk about the first column. But for those involved with potentially utilizing and talking about our next session, this would be important because when we're doing hosting capacity and what Luis had talked about earlier and what Siemens had to do, Siemens looked at voltage, at least only showed voltage in that one map. They may have done other constraint analysis, but when you do hosting capacity, you're usually looking in the model at multiple items. One is voltage, and in most cases, in the low load case where PV is at its highest output and interconnection questions are being brought, it is the over voltage that's worried about. And then there are components about how to think about that voltage deviation both at a customer, on the feeder, and there are different tolerances within the system. So that's what the other items talk to. Thermal. Thermal is the ability of the utility assets to handle the power flow that's required through them at a point in time. So a transformer might have a capacity of 100 kVA. And if the generation requirements or load requirements require it to carry more than that, then the utility should be doing something about it. And I'm being simple. Obviously, everybody that's involved knows that there are different levels that might be acceptable, but that's thermal. When you're doing a modeling, you have a rating on equipment, and so the engineers that are seeing it are seeing whether or not the ratings on the equipment are being exceeded. If they're being exceeded, that's what's being flagged, and that's what will constrain whether you can add new load or whether you can add new generation. So both conditions should be part of your analysis. Also protection. So protection is a little bit less known and talked about. It's not as usually restrictive, but an example of this is 3VO. So I've seen multiple occurrences where ground fault over voltage. So a scenario where the utility at a substation doesn't have the protective relaying to recognize that a fault has occurred to do the proper isolation of equipment. And they have to add sensing and relaying in order to allow additional DG to be added to the system out on the feeder circuits. So in that scenario, in some utilities, that can cost from $200,000 to $400,000 in some cases to put that type of protection in. And so that's very sensitive to developers. So identifying that there are protection scheme requirements and letting developers know that this hosting capacity in this area has a potential implication of 3VO is something that in New York developers asked for. So in New York, when there's a pull down in the maps that come up, the developer gets to see whether or not this protection exists on the station that supplies the circuit. So they know the risk analysis that if I'm the project that creates the need for this 3VO, that's a large dollar figure. It's a lot more than the smaller dollar figures in some cases to mitigate problems for adding a new solution. There are other elements of operational flexibility. So Tomas talked a little bit about reconfiguration on feeders. A lot of the utilities that did hosted capacity on the first pass did it on its normal condition. they don't show hosting capacity on an abnormal condition. So they have to be conservative on tolerance that they're putting in. And what do I mean by that? I'm going to go back, try to show you what I mean. They do the hosting capacity as if the circuit is just a blue circuit and that's it. And they tell you that on that blue circuit, this is the hosting capacity range that you can accept. What they don't do is say that, what would this look like if this transformer 1 on green was out and this switch was closed and now this is all blue? And so that's a more advanced hosting capacity requirement. So that's something that utilities have to try to work in. You wouldn't do that early on, and most of the models don't do that easily. They're more manual. You can create automated scripts in some of the best-in-class power flow tools, but that's not so easy to do. So that's why most utilities don't do it in the first pass.
Maybe if we take 1 minute really quick, Tom. So, Ingeniero Raúl, if there's a way that you can speak a little bit, I think there were some issues in regards to potential availability on feeders that have, que tienen amarres. So, los alimentadores que tienen amarres también tienen la misma capacidad de interconexión. ¿Cómo es que miran a esos alimentadores que se pueden transferir a otros alimentadores?
Sí, que
Sí.
nosotros, sí.
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 Yeah.
Yeah, the ones that actually do that kind of analysis is our department.
Okay.
And the thing is that at the beginning, actually, we did the analysis just as you said, looking only at that particular circuit where you're evaluating the DG interconnection. But during our process, we noticed that it would be wise to also consider these possible scenarios where you could be transferring part of the load to a different circuit, because in PREPA, that happens a lot. We have, as you know, we have problems with some of our circuits, and sometimes in order to continue giving service to customers until we make the repairs, we transfer part of the loads to a different feeders, and sometimes that kind of operations could be happening for weeks. So we have had circuits where we have had to reconfigure for weeks a feeder until repairs are done to the branches with problems. So that's why we also perform that kind of analysis, and we consider those kinds of operations to determine if additional PV systems can be absorbed by the adjacent feeder who's actually now serving the PV system. Yeah, because the location of the PV system changes now. For example, for one feeder, it could be very near the feeder head, but in this different scenario, now it would be at the end of the feeder, and aggregate big capacities at the end of feeders normally cause voltage regulation issues.
Yeah, and I would align with what Tomas is saying from a national perspective. I highlighted just the hosting capacity views. Most utilities who are doing interconnection power flow analysis for an individual application are doing alternate analysis and looking at their normal switching plans, which says how does the feeder change on emergency. But it's very hard to do that on hosted capacity for your whole system. So folks are trying to figure out how to do those reconfigurations, and ADMS platforms are the types of platforms that might allow the reconfiguration, and the planning tools might have to increase actually to be able to run those hundreds of thousands of iterations of modeling you might need to do.
So it's not a secret that Puerto Rico jurisdiction perhaps has highest volume of people interconnecting with the storage system. Contrary that in the mainland. In the mainland, most of the PV system, they don't have a storage system interconnecting with them. But in Puerto Rico, and you can correct me, most of the system now, they are interconnecting with the storage. How that can affect the modeling of the hosting capacity, versus what you experience, which is these are threshold and landmarks, but adapting to our reality.
Right. So you're still going to do all of this, right? But what changes is you need to run a lot more cases. And so what California has done as an example is, in addition to showing PV hosting capacity, they're also showing the ability of adding load capacity. So what you could do when you're doing your modeling is you could do a forecast analysis assuming the storage is not generating anything and you're doing a PV case. And then you could do a second one to derive a different value when the storage is acting as a load. And so so you're bounding the cases, and you would provide two different values in your output. It gets a little bit more complex for the developer on how to use the data. But in some cases, in addition to making it just a visual platform, some utilities are trying to provide downloadable files that provide some of the information that could be used. But that's the next step. One step further than just PV is putting a case where storage is acting as a load versus a generator. And then there's what does the dynamic condition look like, and how much data can you provide and what that might look like. And that's a lot more complex.
In regards to the stability of the grid and the security and there's any report in regards that being made in the mainland that can sustain that position in regards to the PV instability and all this grid security in regards to the voltage and where it's located. But if there's any study that has been done in the mainland contemplating the amount of storage system that are installed in Puerto Rico.
Yeah, Joe alluded to a storage work that the DOE has done. There have been a number of labs that have done storage work.
Just clarification, not utility scale. I'm talking residential storage.
I understand, and they've done residential scale storage. A lot of the question comes into how it's operating. Is it operating autonomously against a set of rules that it's not going to change? Then you could do some modeling to represent it. If it's being changed based upon somebody's desire on a business case, then you now have a higher risk of how you represent it in your model. So it gets a lot more complex. So that's the difficulty, but we can certainly take away that question. And I think I'll ask Patricia and Carolyn if they caught the question correctly, because we can do and see if there are any reports out there. And Jorge has been tapped into some of the resources that have worked in Puerto Rico and see if there's any studies that we could provide to you in the process. Okay.
Thank you. Yeah, we could follow up afterwards. I want to make sure I got that exactly so we can look.
Okay. No, what I was asking is just basically that all the data that I've been listening is just PV, and the interaction. But if there's any report that contemplating the model, because I think one of the biggest jurisdictions that has purchased residential and commercial storage system is Puerto Rico, and that's the manufacturer conception. Right. So if that has taken to accountability, this can be changed and the data can be accurate.
I think it's an iterative process. A lot of folks have started working on PV. Storage is advancing, and I think more work is going into how to deal with this question of storage, whether it's residential or utility scale in the different models, and then how to present information about it. Okay, so I'm very close to my time here, so I'm going to work through a couple of slides. One is This I gave at some point in the past. I want to show again because this gets to the question of what information might be useful on a first pass of hosting capacity. And what this study represents, what I talked about before, is voltage and voltage class equipment make a big difference on the amount of hosting capacity limits. So each of these are different voltage classes, and they go up in voltage class along the horizontal curve. As you go up, this is the hosting capacity. So you can see at 4 kV, they're saying the minimum hosting capacity sits around 1 megawatt. If you have a 12 kV or 13 kV system, your minimum hosting capacity might sit around 3 megawatts, based upon where you are in the circuit. 70 kV circuit is even higher. It represents the fact that in a range of values, hosting capacity is significantly changed by the voltage of the system. And so simple output from this. Another output, and this comes from the case study with Southern California Edison, is the amount of work that the utility has in their program to change out their system. So in this case, they overbuild their system in the construction standards in their 4 kV areas, preparing for a 12 or 16 kV circuit changeover at some point. So if utilities aren't doing this, this is along the best-in-class practices to minimize the amount of changes that have to occur when you convert it over to a higher voltage circuit. This allows you, while you're touching equipment in time, to start preparing it for that higher voltage, because you're never going to get from 50% 4 kV to 100% 13 kV in a short period of time. It's a very expensive ordeal, but every time you're out there working, if you start to prepare, because you're already going to be working on the pole or replacing the pole, putting in the size of a pole that's necessary for the higher voltage, and maybe the insulators, and thinking about the types of transformers that you install with dual taps, that's the preparation that this Southern California Edison example talks about.
Thank you for that information, because in at least in Puerto Rico, what we are doing now, since we want to move the whole system to operate at 13.2 kV in the distribution level, we are at least making new constructions complying with 15 kV class type of construction, and we are using insulators for 15 kV that you could use for 13.2 kV. What we are not doing right now is installing the dual voltage transformers right now. That's something that we have talked with the people of FEMA, that's something that we want to do. But as of right now, PREPA is not doing that. We have plans for doing that in the future, and we have talked that with FEMA, but right now we are not. That's something we're missing.
Right.
Yeah.
That's a good point. These are just good examples of how and why operating voltage make a big difference.
That's perfect.
But
So,
then what is the reason? I mean, it was proposed, it was it was discussed.
Yeah.
And what is the reason that they don't do it?
No. We're talking about the because as part of the projects that PREPA and FEMA are working on in order to reconstruct the system, what has been talked in the projects that are being developed, PREPA is proposing now that since we are in the process of rebuilding the areas that we had problems after Maria, that those areas are reconstructed using upgraded equipment, and that includes using dual voltage transformers.
Right.
That's part of the projects that the government, in this case PREPA, is presenting to FEMA in order to receive funding at the end of the day.
Okay. So it's been proposed.
Yeah,
Okay.
it's been proposed. But as of right now, that's something that PREPA isn't doing.
So Tom,
we are at least, upgrading the construction. The new constructions is being done complying with 15 kV class type of construction using 15 kV insulation. The only thing we're not doing right now is installing dual voltage transformers, but that's something that, as Tom is saying, is something that we should, moving forward, is something that we should consider. If you're going to install a new transformer, for example, a customer has a fault at a transformer and you have to replace it, maybe you could replace it with a dual voltage transformer. And right now, I keep you operating at 4.16 kV, but if in the future we are able to move forward the voltage conversion policy, then when I get to your house or to your transformer, I wouldn't need to change your transformer. I just move the tab and make it operate at 13.2 kV.
That's right.
That's the mindset, and that's the plan that we would like to enforce. We've been trying to move to 13.2 kV since I was born. Was in the 70s, so it's taking us a while to do it.
So Tom, as every other utility. Yeah. I'm going to keep saying this because it's not, you're not that different.
Yeah,
every utility is struggling with the same thing.
So going to the slide back, just one slide back, the slide that you had the dual transformer, right? So on that depiction, the dual transformer, can I consider that a best practice?
I think best practice is a consideration for dual, whether this was in Southern California.
So I can
they
consider
stack
that to be
feeders,
best practice. Okay.
But many utilities use dual transformers for those configurations, so that to the point that Tomas said, when I'm doing the changeover, I don't have to replace the transformer and then have an asset that I can no longer utilize. Maybe I have to install it somewhere else on failure, but it increases the utilization of your assets. So
I'm just curious, in that case, for that dual voltage transformer, is it more expensive than a 4 kV or the 4.2? I think it's absolutely the right answer. I'm guessing it is.
It is.
It seems like it's the right answer in the long term, but I just as a question to Preb, is there? I've also heard questions of you have to go for the lowest cost option. So I just want to make sure that in a long-term planning sense, I think that's the right answer. I just would tee that up as removing barriers, as we were talking.
Yeah, is the lowest cost option when you consider the benefits? Yeah. So
it's the and when you have the full business case, assuming the changeover, that might be 10 years away.
Yeah.
But some of them might be closer. So you may have a locational decision to make that I will do it on these circuits rather than other circuits.
Sure.
So.
I'm just trying to think holistically to make sure that, communicating as broadly as possible to take away those roadblocks that could possibly prevent from doing the right thing in that example.
So I'm in my last couple of slides here, and we're going to talk more about this in the next session. But folks have started to talk about this today and many times, and I want to give some of the examples of what increases hosted capacity on the utility system and what areas should be part of the consideration. So number one, actually, let me just say that there are basically 3 buckets of areas that I would characterize. One is grid side enhancements. That is, what is the utility doing on its grid and the implications of how that changes? What are the operational changes that are part of that? And then what are some of the customer side solutions behind the meter that would have an impact? So the grid enhancements, so Tomas and others talked about this today. What do you pay for when you're trying to do interconnection? Line reconductoring is one way where the circuit, the cable is too small and it needs to be upgraded. Line reconductoring is a tool that increases the amount of hosted capacity. It does that by reducing impedance. So circuit reconfiguration is another, and the ability to get the DG closer to the substation would imply that it will have higher hosted capacity. So circuit reconfiguration, hit him, would you? Circuit reconfiguration is one of those answers to help increase hosted capacity. Transformer replacements, Jorge alluded to this. In the case where you have multiple residential PV systems that are higher than the size of the transformer, you may have to replace the transformer. And that might be enough to mitigate the local problem. You have voltage uprating, we've talked about that. Here you start talking about communication and control. So Andrew talked about this with regards to how do you advance the tools so that you can control voltage better and do it at much closer areas to the customer and the DG. That can help you to manage the hosted capacity in a local area. As I talked about, there are some protection concerns that impact hosted capacity. By updating relaying, not having in some cases mechanical relaying and having more digital relaying, will also impact and your capabilities. Your modeling data. So we talked a little bit earlier. Your hosting capacity assumptions are going to be more conservative when the quality of your data is poor. The better the quality of data, the less risk you have in your assumptions, and therefore you're going to have better hosted capacity results. And the example we talked about a bit was better understanding where the load is on the circuit by monitoring it at different points would change the assumptions being made by the design team so that they can better represent a lower risk host capacity number. So that's the grid enhancement views. There are operational changes that utilities can make associated with this. Voltage regulation. So we talked a little bit about mechanical regulators, solid state transformers is an option. They operate differently. They can control VAR. And so there are components to do that. Distributed grid edge volt VAR control. So there are new tools, a lot of vendors out there working in this space, where you would put a device on the load side of a distribution transformer, and it would clean the voltage up and manage the voltage within a range. And the range tolerance can be up to almost 7% change. So if you pay the money to install that type of device on the load side of a transformer that's experiencing problems, that might be one solution. It's also a power quality solution that the power quality problems could be emanating from very different types of reasons. So those are tools that are used for different functions. And then relay setting modifications. So if you can change some of the settings on your circuits based on what you know, you can also impact hosting capacity. And then this gets to the customer side solutions about the types of things that can happen. Smart inverters, there are a lot of people talking about this as major benefits that could be provided in managing the hosted capacity. And it's done in a lot of different ways, but the more simplistic ways that some utilities have started to introduce them is using what's called autonomous functions of the smart inverters, and that would be power factor or VAR control, volt VAR control functions, so that the smart inverter would have a set of functions. You would choose the setting on the functions, and then it would operate within that setting autonomously without interjection. And in doing so, it will help to mitigate the voltage rise that you would otherwise see. And so it would be a tool to allow you to marginally impact the voltage rise. And not a major solution for a very long circuit, but a solution in many different areas. And this is already being done by quite a few utilities. Distributed VAR control, so there are more advanced tools to do VAR control on the customer side. So now you start to think about targeted placement. Where can I put these devices to be closer to the substation? There have been studies out there where you can get step change in hosted capacity by incenting or targeting installations closer to substations, and therefore the further you get away, the lower the hosted capacity, the closer you are to your station. You in fact get a higher increase and a better optimization of the DG being installed. If you can make it dispatchable, curtailable, then you have a potential to manage the DER. You can also increase hosted capacity. Simplistic PV panel orientation is very important. What is the orientation of the panels, and how are you thinking about them? Are you thinking about them? And whether or not what are their outputs? And so those are components that are often considered. And then the passive side of this is just understanding DER, not PV in this case, demand side management programs to manage load in certain areas, to incent areas to change load profiles that have a better confluence of value with the PV. So down to the wire on the last two slides that I had is We talked today about value propositions. The whole first part of the day was about why and what business case are we going to consider doing this. And there's a cost, so you need to align a value proposition. We need to get alignment across the different areas about what use cases make sense so that we can feed the recommendation into the commission. And we talked about some of the ones, and going forward, I think we want to dig a little deeper into what a proposal might look like. We got to look at data privacy. So when you make transparent data out in the public space, there's going to be questions about what are the limitations of that data. It's been dealt with quite a bit in the customer data world, where you're exposing customer data and who's allowed to see it and who did the customer say it was okay to see. But in the system data world, it's less obvious. There are some examples out there, but Puerto Rico needs to make its own decision on that at some point. Through recommendations from this team might benefit the commission in considering that. Communication is very important, and that was one of the items that was brought up earlier on the developer side. If you're going to do hosting capacity, you need to communicate what it means. You need to communicate how and the assumptions that were used, and how it could be used, and how it probably shouldn't be used yet. So along the process, if you advance your capabilities, you might suggest that you could change its utilization a bit and use it in different ways. Early on, it might be just good enough to kind of get an idea of what real estate you should be looking at. The second piece of that might be, hey, can it be used as a technical screen? Is the data good enough for that? And have you tested the data to show that you're confident enough to do that? And then costs. So a number of folks have brought up, how do you consider about a roadmap of advancement, and what are the implications of costs? And a lot of these cost components are going to be derived from PREPA information about what they think is necessary to get them the tools that are used. And some of that consideration, ideas of scale is important here, and talking about it so that there's a reasonable expectation of what that cost looks like, and it would be acceptable in the greater scheme of things. So this gets the potential steps, and I think Jorge is going to jump in at this point. But I would say that you have to look first at what some jurisdictions have done with some of their visual maps, and think about the stages. And if you just said, give me a heat map that shows me the different voltages, that is already telling. If you're trying to connect PV systems that are not residential on a 4 kV circuit, it's very limiting. If you're trying to connect PV circuits that have a higher voltage, there's generally going to be more capacity. So that might be a simple first pass just to do it, and the GIS system doesn't need to be perfect to do that. And then the other elements would be to request PREPA to consider and propose on an approach to calculating hosted capacity. So we were thinking that we would bring in some other experts that have done these types of calculations. We said we might talk with EPRI to see if EPRI would make a presentation to talk a little bit about more detail about how they think about hosted capacity. I've given you some views of it, but you would be a little deeper dive into the type of tools that exist. And then there are different methods. I haven't talked at all today about a streamlined method, an iterative method, and the tool implications in all the types of things. We've talked about the implications, and we talked about the type of things you look at. But then there's the question of how do you run it, and different than how you run an individual case using Synergy as a model. And then for the next session, we're talking, we really want to talk further about the ability to host energy storage and the implications, and thinking about that in phases, and the ability to host EVs. So the question of hosting capacity as a PV type system or hosting capacity as a load. Two different views, two different considerations. So that covers my stuff for today. Thank you.
Any questions? Any comments? I thank you.
Okay.
Thank you, Tom. I could safely say that this is one of the the most relevant presentations that we have seen Fantastic job, Tom. The good thing about Tom, he's going to be with us through the stretch of the initiative, and we have the commitment to actually get that support. Thank you very much. So while I'm saying that, we are going to have Vanessa. Vanessa is going to have a very short presentation because she's going to be showing us how to use Microsoft Teams. The initiative has the ability to actually utilize a digital space that was created for this specific working group. Lo voy a cambiar en español ahora, así que los que tienen el auricular, Vanessa, la ingeniera Vanessa Carón nos va a enseñar cómo utilizar el espacio digital de Microsoft Teams, que lo tenemos dedicado para este esfuerzo. Todo el mundo debería haber recibido una invitación y ella nos va a dar más información. Ahora, no sé si se recuerdan que durante la mañana les pregunté que le iba a hacer la pregunta, que quiénes ustedes creen, qué otros tipos de participantes deberíamos considerar traer a este grupo de trabajo de capacidad de interconexión. ¿Alguna idea? O sea, tuvimos un desarrollador de utility, el licenciado Párez es un desarrollador a nivel de residencial. Tenemos a Laura y a PJ de la asociación. La utilidad, tenemos un consultor de la utilidad. ¿Alguien más que deberíamos involver, traer, invitar?
Quizás no necesariamente de hosting capacity, pero esto que está ocurriendo sobre los vehículos eléctricos,
sí.
A mí me gustaría, pues yo no he tenido oportunidad de hablar con nadie que desarrolle infraestructura para vehículos eléctricos. De él no he hablado con nadie nunca, pero por lo que yo leo en papers y documentos, ¿verdad?, de internet, he notado pues mucho interés de las personas en los vehículos eléctricos y nosotros no debemos quedarnos estáticos de lo que está pasando y pensar solamente en generación distribuida, porque los vehículos eléctricos es algo que va a pasar. Quizás no pase con la rapidez que pensamos, porque quizás no todo el mundo ahora mismo los puede comprar, pero como todo en la vida, en algún momento va a ser accesible y yo creo que sería bueno que si es que hay, ¿verdad?, en Puerto Rico, no lo sé, algún recurso que esté vislumbrando el desarrollo de vehículos eléctricos o estaciones de carga para ellos. Alguien que esté en ese ambiente, yo creo que sería bueno, no necesariamente para hosting capacity, pero para este proceso de planificación, yo creo que sería bueno que alguien que esté viendo ese mercado pues pueda proveer un poquito de luz, ¿verdad?, de cuál es quizás cómo ellos visualizan que sea el desarrollo de ese mercado en Puerto Rico, por ejemplo, para que lo tomemos en consideración, porque pues es una carga que ahora mismo no tenemos y pues como habíamos hablado la otra vez, pues probablemente todo el que compre vehículos eléctricos en su momento, pues lo va a conectar. Si es en su casa, pues cuando llegue y todo el mundo llega aquí a la misma hora, los tapones son los mismos en todos lados, todo el mundo llega a las 9 de la noche y a las 9 de la noche yo pongo el mío, mi esposa pone el de ella y así todo el mundo. Entonces tenemos que estar seguros que el sistema de distribución tiene capacidad en transformación, en los transformadores, por ejemplo, para manejar esa carga a esa hora del día. O si no es así, si vamos a querer implementar tarifas de horas de uso para cargarlo, pues que desde ya vayamos visualizando, o sea, no esperar a lo último, poder desde ahora irlo teniendo en mente para que lo consideremos.
Definitivamente, o sea, ok, muy bien, lo apuntamos. Tengo entendido que el programa de política pública energética tiene un programa, pero se hace reach out. Sí, listo.
Ya hay gente. Por eso es que a veces lo que estamos en la comunidad, por eso es que yo estoy aquí y tenemos más conexión con este tipo de personas. Existen ya las personas, yo he estado conectada y esto no es de ahora, esto hace muchos años atrás con UHBC, que estaba el arquitecto Abruño aquí, que me gustaría también que fuera partícipe dentro de esto, porque estamos hablando de la parte de arquitectura, ¿no? Sí, yo he estado con él y he hablado muchísimo con él. Existen y por eso es bueno seguir buscando, seguir tocando esas bases porque todos estamos relacionados a lo que está pasando. Otra de las cosas, esa participación activa de lo que está pasando, por eso vuelvo y repito, esta parte de la comunidad, ¿cuál es la necesidad? ¿Qué es lo que se está haciendo? Han mencionado muchísimo el de abajo hacia arriba, pues vamos a buscar en realidad lo que está pasando, más en las partes vulnerables que somos en el centro de la isla. Así es que eso estaría sumamente interesante, importante que tener esa participación de todo para saber dónde estamos.
Ayer tuvimos al Consorcio de la Montaña, también tuvimos, sí, nos vinieron gente también de Jayuya, también nos vinieron, y es muy importante hacer el outreach. Outreach más a la isla, outreach al programa Política Pública Energética, al arquitecto. Ok, eso es importante para la próxima sesión. Sí, enero.
Quisiera añadir también que también sería bueno considerar los programas de eficiencia de energía como parte de la industria cuando van a presentarle los proyectos a los clientes de instalar sistemas fotovoltaicos, ¿verdad? Que de alguna forma se evidencia de que se le hizo un estudio y una auditoría de cargas y que se le hizo recomendaciones o se implementaron para mejorar la eficiencia energética ¿verdad? en el site antes de proveerle entonces una solución fotovoltaica o de energía renovable.
Y eso viene bien porque eso redunda en
beneficio.
Eso que menciona Raúl es bien importante porque eso al final del camino también redunda en costos más bajos para el cliente en cuanto a la generación que necesita para suplir sus necesidades energéticas. O sea, que es importante ese análisis, que me parece que en Puerto Rico no necesariamente eso se hace. Yo creo que típicamente lo que se hace es utilizar una factura del cliente, ven cuál es su consumo promedio, lo llevan al año y sobre eso se hace el diseño del GD. Pero ciertamente si consideran mejor eficiencia energética, poner equipos más eficientes, ciertamente la capacidad entonces del sistema de generación que necesita puede ser más pequeño. Y si va a instalar una batería, pues probablemente en vez de tener que instalar dos, puede instalar una. Son cosas que es bueno que lo consideren, ¿verdad?
Yep, I can. But to respond to that, that is a great idea. There's this whole national campaign called Efficiency First. Like there is so much energy wasted on this island, and just identifying what that is, a lot of times it could be really cheap to address it. From my experience, those work best when they're paid for by somebody, because a solar company it's really expensive to drive out and do a detailed analysis. And it's not necessary to give a solar quote. They can say, oh, show us your PREPA bill. Okay, great, $20,000 for a system. But to actually do a study, that might cost $500. So who pays for that? Solar company don't want to pay for it. The customer doesn't want to pay for it. So that is an example of a really important component of energy efficiency programs, which are now paralyzed, and the law might be being erased right now. So the question on the table, I think, is who else should be here, and I think that it's really important that we all learn from that lesson of like something that was really important to start, like just got stopped politically and would have included that exact thing. So to have a broader stakeholder outreach program is important. One voice that I see missing from all these policy conversations that makes me really nervous is that there is no one here representing the consumers. Like what I'm used to, I come from in Missouri, is really strong bulldogs representing the consumers. You have Walmart there fighting. You have the industrial groups there fighting. Commercial groups fighting. Residential, AARP, just absolutely fighting for their interests, which is their consumers. We don't have anyone here doing that, so we all care about the consumers. We're all consumers ourselves, but no one is looking through that lens. Frankly, I am really worried that the Office of Consumer Protection here isn't here. They're legally required to be here and to be fighting for consumer interests, but they're not. They do not show up at these proceedings. They don't participate. They don't represent consumers, and I think it's a really big problem with government here that we don't have a consumer advocate office that's active and doing what it's legally required to do. I think maybe AARP would come if we just invite them. I think the Manufacturing Association might come if we just invite them to be representing that consumer voice and validating the things that we're developing here and telling their stakeholders about it. But it's just a voice that's missing and makes me really concerned, because when it's not here, then everything we're talking about costs money. So when we don't have that consumer voice here, I think what we just learned 2 weeks ago is that we see it all over Twitter and the newspaper and this huge public backlash because they don't know what's going on. So the average consumers don't know. They should be looking forward to, there's this free energy audit program coming out. Not saying, if it raises my bill by 1 penny a month and I hate it no matter what. Like that consumer outreach is I'm really nervous that we don't have that voice here.
Thank you, PJ. Appreciate the comments.
Aquí. Yo también pienso que la academia tiene una relación muy importante. Estudiantes de ingeniería en su último año pudiesen ver un espacio para ver un nicho. Hay otra aportación de mi parte que yo estoy generando. Yo estoy en la industria de promover un negocio y estoy promoviendo un diseño de una unidad móvil que me permita vender accesorios de primera instancia para los consumidores como yo que nos pasamos en la calle, pero a su vez estoy buscando el patrocinio de personas que tengan interés que yo desde mi unidad le pueda recopilar una data. He mencionado en anterioridades que es importante conocer la parte socioeconómica de nuestras comunidades. Así que con esta unidad móvil yo voy a romper con el hielo, esperando que la gente responda a ese boom, ¿verdad? De cómo yo llego a buscar un equipo ajustable a mi necesidad, pero a su vez tener el enganche para tener una apertura de informativa y de información, ¿verdad? Ya yo tengo un borrador de cuáles son las preguntas que tal vez pueda estar haciendo en ese cuestionario y yo sé que me he movido, por ejemplo, le hice el acercamiento a la directora de Bosque Modelo que está en la zona rural y que ella recibe mucha participación y con ellos tomé yo una capacitación de 250 horas en energía fotovoltaica con la Universidad de los Pies Descalzos de la India. Fuimos de las 24 mujeres que se capacitaron en la Hacienda Juanita, donde recibimos esa capacitación desde crear un board y acercarnos más a la necesidad de otras partes del mundo que no son las que nosotros tenemos, ¿verdad? Pero sí nos da la empatía de poder comprender que sí podemos empezar desde cero, ampliando nuestra visión y la necesidad que tenemos. Así que yo voy a estar por ahí moviéndome porque mi interés, yo le comentaba hoy a Ada, nosotros somos parte del problema, somos la solución y que a veces miramos a prepa, nos quejamos del sistema energético, pero ¿qué hacemos nosotros desde nuestras propias instancias, verdad? Así que con este modelo será uno micro, pero es mi sueño, el poder yo llevar esa información y recuperar esa data, porque si eventualmente ya sabemos que la data es importante, que tenemos que saber con cuánto cuentan las familias para poder accesar a sus servicios y cómo lo vamos a estar trabajando. Así que más adelante voy a estar compartiendo mayor información sobre este concepto.
Muchísimas gracias por su participación. Sí. ¿Tienes micro?
Also, it's important to have the Energy Public Policy Office of Puerto Rico. Oh, who? No. Okay. There's two offices, OIPC, which is the consumer, and the other one is the Public Energy Affair Office, Puerto Rico Energy Affair, because in accordance to, and I was Googling their faculty are the responsible and the representative of the executive branch before the Bureau, and they're the people responsible to be in the relation with FERC and DOE. Actually, it's the mandate of the law. because and so the executive branch also can be aligned and they can present at the end their position, and they're responsible to gather the data. So and now it's the public energy program, which is a part of the Commerce Development Office. So they should be invited and they should be here.
Thank you for sharing. Thank you. So we're going to have, tenemos a Vanessa para que nos dé la presentación de la espacio digital. Vanessa.
Hi, good afternoon, everyone. A few of you were here yesterday, so I'm sorry for repeating. So basically what I wanted to do was just show you a little bit about the workspace that was created in order to facilitate communication between and among stakeholders with the Energy Bureau. So basically, most of you or all of you should have received an invitation to participate in this workspace. If you have not received that invitation, I will keep a list out on the table, so you can just add your name and your email address so we can add you to the workspace. So basically we are using Microsoft Teams. This is some sort of a chat where we can just input our recommendations, our suggestions. Also, we can share files that can be put in here. So basically, I have added the agenda for today's meeting. And as we continue to work throughout this process, all of you and I will be sharing information here, as all the slides that were presented today, etc. So we can share this information and learn from this information. So what I wanted to do was just read out the use terms and conditions a little bit for the workspace. So all of you are aware that you should have received this also with your invitation, but just to let you know again. So the materials and information on the digital space are provided by the Energy Bureau and or its consultants' resources for informational purposes only and should not be construed as policy-making determinations by the Energy Bureau. This digital space should not be used for the advertising of any products or services. It should not be used for the transmission of content that is illegal, vulgar, violent, inappropriate, or that in any way may be deemed offensive. Please do not share personal or private information. Do not make any libelous or defamatory expressions. Do not incur in any act that may infringe intellectual property rights. And the digital space, and as the other stakeholder workshops previously held by the Energy Bureau, shall be governed by a modified version of the Chatham Rules, which under those rules the participants are free to use the information received, but neither the identity or the affiliation of the speaker nor that of any other participant may be revealed. So just going back to the workspace, and again, if you have not received an invitation to participate, please let me know so we can add you. Also, we have created a similar workspace for the other working groups that we have created. So if you are interested in participating in any other working group, you may tell me so we can add you also to those working groups as well. So, any questions?
I have a question that came up earlier
Mhm.
that maybe involves you, that doesn't have to do with this, but actually it's something that I would like to post in here that I think would be
Okay.
helpful. Earlier I think it's really important that we have information about what we're currently hosting right now so that we can predict where we're going to grow. I think that there's a report that PREPA has been sending every 6 months that says the net metered systems, how many there are, megawatts, kilowatts, and how they're and where they are. if that if that's something that's publicly available or could be made publicly available, I really just want to make a chart of what was hosted the last time that was submitted, if that was 6 months ago, and then a year ago, and a year and a half ago, so we can start to see the trends. Is that something that's in your hands or your responsibility, or how could we get a hold of that data to work with here as we're trying to figure out how to grow the hosting capacity to see what is being hosted right now?
Well, we, as of now, have a proceeding open regarding the progress of interconnection. So that is another case that we are dealing with. But as of your recommendation and your suggestion, I can go and verify with the commissioners how that information that may be received on the other docket, and if it is public, we can share in this docket too, and through this workspace in order to facilitate for you guys. But I have to check with the information that has or will be received in order for me to share.
Thank you. Yeah, I mean, maybe there is a docket there, and I just need to know the docket number, and it's all posted there already. I don't know. I'm guessing not. I'm guessing it's probably information that's submitted. Maybe some of it's confidential if it says this customer names or too granular. But if it's there in a big spreadsheet, maybe it can just be summarized in a regional way or in something that could be really valuable data. Mm-hmm. And if it's there, if you could look into that and report back, that would appreciate that.
There's something that I do have. I do have a graph since 2008. I think we started integrating PV systems in 2008, and I have a graph from that year up to December of 2018. I do have that because I'm the one who prepares that graph, and I have the graph of the trending. The interconnection progression of PV systems in Puerto Rico as an aggregate per year. I do have that. I have at least a graph that has information on the aggregate capacity and the total interconnection of PV systems in the distribution grid since 2008 up to 2018. I do it annually. Because it's hard for me to present the data on a monthly basis, but I do ask for information on the final amount of interconnections at the end of the year, and I add that to the graph that I have, and that's what I present every year. I do have that, and I have used that on public meetings and presentations. So at least as of year 2018, I have that, and I can bring it down. I've made it public before, so
yeah, I think that would be really useful if you could post it in this work group and bring it.
I can bring it for the next meeting, and there are no names in there. I don't have information on customers or anything like that, or the specific capacity of any customer. So since it's aggregate information, I think there should be no problems for me to.
It supports the working group efforts.
Yeah,
absolutely. Yeah.
And that'll be helpful at the highest level, but I would love to have at least like at the regional level. Is that report every 6 months sent by you to her?
But let me go ahead and interject really quick. So remember, PJ, that this is the information that we're getting from him is to support this initiative and this working group. In regards to the interconnection proceeding, we need to compartmentalize those. So I understand there's some correlation between both. So whatever we bring is to support this initiative. Yeah.
Just a question in regards to the data, and it's the following. After Hurricane Maria, some system, they went out because they flew with the storm, the snow. But also there are some applications, and then people say, no, I don't want the system because I will relocate to the mainland, I have another job, I will move. If those data can help for the hosting capacity to understand that, or if that is something that can be future update to see which of those requests has been finalized and they're actually producing, that can affect the capacity. I think that will be something that to consider. I don't know.
I have something to say. There's a company in Ponce, in front of the bypass, a manufacturer that went out of business, and it's a Pritco building, and it has 1 megawatt of capacity on top of it. So they are trying to get rid of that. I don't know if it is online or not. I believe so, but the actual facility closed down. You still have 1 mega on top. They used to have a net metering, and it's gonna go out because they moved out back to the States, and they're gonna close that business, give back the building to Pritco. And that's one consideration for all of us to take into account, because if it is going to be online or not. And the other case is that, in our experience after Hurricane Maria, the major systems and what we deployed from a company perspective, all of our PV systems for clients were evaluated, put back to work. So for example, the many hundreds of kilowatts that we had installed in clients were assessed, fixed, and they're back up. I'm getting I'm getting a request from a client to now these days to go out to the San Lorenzo and assess a 500 kilo system that is out. So there are things like that then we need to have an asterisk on your graph.
And really quick, before we address all this, if there's anything else for Vanessa and the teams, any questions for her? Okay, muchas gracias. Okay, so you can go ahead. I'm going to set up right now.
In what he's talking about, if a customer wants to disconnect its system from the grid, there's a procedure that customer has to comply with that is included in the current regulations. That person should contact PREPA, fill out a form that that he's going to permanently disconnect the system. He's responsible for that. He should do it. And that way, PREPA knows that that actual customer is disconnected from the grid, and that's important for us to know, because that could change the capacity that a feeder can absorb, for example.
I just got notice of that because another client of mine was offered that megawatt by this other person. So I drove down there to Ponce. I arrived there, talked to the guard, and he said, "No, they're gone. They're already in the States." So I explained to him, try to get me a contact or what have you. So I did try to reach out, but we may need to go through Pritco.
The thing is that since it's interconnected, they are still responsible for it. If something happens, there's a signed contract with PREPA, and they are still responsible for that interconnection. So that's why if you can contact that person, let him know. Please. That there's a process.
I'm trying to contact them.
Please.
Thomas, a question: the data that might have or what is application or is production? And let me see, I was in Spanish, so I'll be.
Sí, puede hablar en español.
I'll say in English. The information that you guys have is in regard to the application that companies and developers had filed before PREPA, or is because actually system production?
No.
That is not.
No.
So I'm saying this because executive order of the governor said everyone can interconnect, and a lot of cases were like, boom, approved. But when you perhaps can go to the site, there's no system installed. It was just an executive order, and sometimes you can see the approval. So I'm just saying, because then some of the information can be mislead or
at least
the
for
capacity.
us, the information that we have in the database is in regards to the capacity installed of that customer, not necessarily the production. I mean, PREPA does have a meter at the installation, but it doesn't measure the actual energy produced by the PV system, because that meter only receives information of the net exported energy. So it would be great for us to have the production information of the PV system, but as of right now, we don't have metering equipment at that
generation
point.
Behind the meter, you don't have access to that.
No, behind the generator, no.
All right, guys, we are in the final stretch. So, esto es lo que necesito que hagan, por favor. Nosotros vamos a pasar como los últimos 20, 25 minutos. Hay una hoja de trabajo en sus folders que se llama discusión sobre mapas de hosting capacity. Y lo que vamos a hacer ahora lo vamos a hacer en grupo, hablándonos entre nosotros. Y hablándonos entre nosotros podemos capturar lo que estamos buscando de este ejercicio. Lo primero que tenemos que identificar es lo que vamos a buscar es qué información estos mapas de hosting capacity deben de ilustrar y por qué. Aquí le estamos dando un ejemplo de diferentes alternativas. Está la alternativa de hacer una lista. Se puede hacer una lista. Ya la Autoridad de Energía Eléctrica tiene una lista, ¿sí o no? Y en esa lista tenemos 2 alimentadores, ¿listo? Que están como que un poquito restringidos. Además de la lista, podemos tener lo que se llaman unos heatmaps. Estos heatmaps, déjeme sacar esto, Alfred. Los heatmaps ya tienen información un poquito más geográfica, pero no es tan granular, ¿no? Y entonces también podemos tener información ya a nivel de alimentador, donde tenemos los colores en el alimentador y tenemos exactamente la calle donde están. ¿Listo? Además, entonces, estos son alimentadores a nivel primario. Donde tendríamos entonces, sería necesario tener información de alimentadores a nivel secundario. O sea entonces, en este momento lo que estamos buscando es qué información estos mapas deberían de ilustrar. ¿Cómo se debería representar esta información? ¿Queremos mapas? Yo creo que tenemos un consenso que queremos mapas, ¿no? Queremos mapas. Y en los mapas, pues, ¿qué información? ¿Cómo se quisiera representar esa información en los mapas? ¿Cuánto nivel, por ejemplo, cuánto nivel de granularidad necesitamos? O sea, ¿estamos buscando un mapa que nada más diga estos son los alimentadores que están restringidos? O quizás queremos una granularidad. Por ejemplo, aquí tenemos una granularidad de... Aquí hay una granularidad de 6 niveles. Entonces tenemos que empezar progresivamente, o sea, si en este momento sabemos dónde estamos, lo que estaba hablando el grupo de acá, si estamos en este momento aquí, ¿cuál será el próximo paso? Pues ahora en este momento tenemos una lista, ok, pues entonces, ¿cuál es el próximo paso de la lista? Pues un mapa, ok, en ese mapa vamos a tener un heat map con poquita, por ejemplo, con esto ya esto es suficiente, o sea, si tenemos como que una nube en un área, ¿eso es suficiente? ¿Is enough? Por ejemplo, para Luis, ¿esto se te haría suficiente? ¿Tener la nube? ¿O tú quisieras ya algo más? Yo quiero ver toda la calle, o sea, quiero ver esto no es ni un bloque, esto es un parque. En este parque estoy verde y ya pasé este edificio, ahora estoy rosado.
Parte de lo que hablamos ahorita era que debe haber dos there should be two forces working now. One force should focus on solving the requests, the initial demands for interconnection right now. For example, the amount of clients that he has, that somebody should evaluate if he can connect where he needs to connect because he's selling right now. And the other thing, it should be the correct path to develop the level of granularity and the level of information to sustain the path from 3% to 100% in the stages that maybe it's baby steps right now, but maybe it's in periods of 3 years, 5 years. It doesn't need to be perfect in the next 6 months, but it should be sufficient to allow the integration or in an organized manner, and then to have a path to develop something functional, available, because this is going to drive even the economy.
So now driving from what we learned from Tom, right? So we are going to go ahead. This is going to need some sensing, right? We're going to need some sensing. So probably we have some power flows already.
And the other thing, this need to incorporate at some point, maybe not right now, but maybe the intelligence will give us this information down the road if we have what kind of equipment we have interconnected. If that equipment is intelligent enough to react and help the grid. If that equipment or that system has BESS, if it has a battery energy storage, if it could give out a power factor correction, reactive power. So right now, no, we know it's not going to be done in the next couple of weeks, but we need to help our utility to be able to accept us and have a permanent plan to develop something that is very useful, because it will be needed if we want to drive to 100% renewable.
So what will be useful for you, Luis? Would you like to know available capacity, for example? There are 6 megs.
Right now, for example, if I need to solve a situation, I would drive myself to go to Peña. So I need 10 Peñas.
Yeah.
So
true.
because I really would need him to be 10 times comfortable answering to me if I can connect this amount of people.
So now, can you say that again? So your hosting capacity information is to go to the engineer directly to ask for a specific answer, can I interconnect? Basically.
That's the immediate need that we might have on the commercial side. Then for the permanent solution or a good planning strategy to allow this to happen is to develop something like you're showing there, right there.
So available capacity will work. What about restrictions as a function of the 15% rule? Even though we have been talking the 15% rule being obsolete, but is that like a phase 1, phase 2? Knowing that we don't have too much sensing capacity, but maybe with the power flow models that you already have? Is that like a phase 1? I mean, we're phasing this in, right?
Yeah. But remember that initially what we get is a go or no go answer from him. So right now it's a binary, 0 or 1.
But there's something that I need to address, and it's not about them.
Because
it's about
whenever
the
you tell,
regional office.
if you tell a client that needs to put down some more money, then the system gets
Thomas, just
delayed.
a quick question. Does the regional office, which are the ones who will be managing this data, do they have access to this data right now, or is just in Monacello in the planning?
The what? Sorry,
The regional, la técnica, las oficinas comerciales.
You want to know if they have that information?
No, if they can access that information, because they're the one who do the first evaluation or the evaluation for you guys to. They're the one who provide you guys the information.
Yeah, well, as of right now, right now we don't perform those kind of maps. But when we do perform a study, we send the results to the personnel at the different regions. We have in PREPA 7 regions, and for a particular feeder from which we perform a study, and we come up with our recommendation, we send them the results.
Okay.
So they receive information on the power flow and what we got from the analysis.
So the regions, they don't have access to like the feeder information. So they are like your client in some kind of way.
No. They do see the feeder information. Yeah, because they have access to the GIS. Yeah. Oh yeah, they have access to the GIS, so they know the infrastructure they have in a particular place. Sometimes they need to send somebody down to the field if they find out that you're going to interconnect a system, and when they go to the GIS, they don't see you in the GIS, or there's information that's not there. Then they send someone to check it out. But yeah, they have access to the information. Yeah. Yeah, we have regional. PREPA is divided in 7 regions, and every region has personnel who actually receives the interconnection request, and they by themselves they perform the first evaluation of the PV system. If it doesn't need an analysis from our office, they complete the process by themselves. The list, it's not a big amount of interconnections that come to our office, actually, because there are thousands of PV systems interconnected in our system, and we have performed, hundreds of evaluations, but not for all the customers who have interconnected to the grid.
I've got something really important to say now, because that regional approval, who is the boss of those regional approvals? Who's overseeing the standardization of those? Is there anybody?
No, pero por encima del superintendente, el director de T&D, ¿verdad? The director of the Transmission and Distribution Directorate.
Sepulveda? No?
Sepúlveda, yeah.
Sepúlveda, okay.
Yeah, he's the director of that area.
Okay.
So he's the one who actually enforces, the instruction on how to evaluate the interconnections. And well, actually, there's a regulation. Yeah, actually, there's a regulation, and he makes sure that he enforces that the regulations are followed as they are established. So, and if a customer finds out that an area is not completing the process as established in the regulation, that person or customer can actually escalate his petition to the director to Sepúlveda, and he can, deal with the situation that's happening over there.
All right. So going back to the maps. So the maps. How often do you think? Well, let me ask a specific question. Do you think that on these maps we should display where PV installations are already deployed? So we have a map of this is where I got a PV facility, so people can look at it and at least you have some kind of visibility. Is that something that these maps should include also? Like for example, I am a PE, right? I went ahead and I.
Tomás, Tomás, Medero, el que estaba ahí. Medero nos enseñó el área de la región, de esa región de la piedra. Y él me mostró en su máquina, ¿verdad?, una ilustración del alimentador y él dijo, en esta área lo que hay son unos pocos GD. O sea que hay alguna información que está en algún sistema de la autoridad.
Oh, sí. Toda la información de los sistemas de generación distribuida que se han ido interconectando con la red de la autoridad.
El circulito que yo veía que decía una palabrita.
El símbolo que tiene GD en el GIS, esa es la ubicación de un sistema de generación de algún cliente.
Okay,
si
o sea que por lo menos sí, aunque no tenga una leyenda y un detalle y una sumatoria, aunque no tenga los goodies,
lo que pasa
hay
es
una ilustración básica de unos puntitos en el mapa.
Sí, lo que pasa es que ¿verdad? Si esa información, ¿verdad? Tú puedes, depende cuánto detalle tú quieras, tú te vas acercando en el mapa y puedes ver, ¿verdad?, hasta dónde discurren las carreteras.
Pero eso es Medero, yo no puedo hacer eso, ¿verdad?
No. Sí, no, porque eso es información de GIS, ¿verdad? Información de la infraestructura eléctrica que tenemos.
Sí, porque la pregunta es que si se pudiera hacer, por ejemplo, snapshot.
Sí, esto sería para el público.
Hacer un PDF, ¿verdad? Sin nada privado y por lo menos uno ver dónde está algo en el mapa, porque yo nunca he visto un mapa de eso
So my thought is this, and this happens when you start getting distributed energy resources bidding into a transmission system market. Okay, you need to know what capacity you've got at the distribution system level. I don't think you necessarily need a map, but you need a registry. You need a registry that says, right, which is your own database, which says, this is what my customers have. This is where they're located, right? You need that minimally, I think, whether it's on a map or not. I don't know whether you agree with that, but yeah. A registry of exactly every single DER that's on the system.
Yeah,
you need a registry.
And Joe, I'm with you. Prepa, as of right now, before 2017, we were having a manual database, where we have in Excel a database, and I had an employee at that point, and she was incorporating every DigiSystem that was interconnected around the island. Every region was sending all those interconnections to my office, and I had a secretary at that point, and she was putting that information in the database. But then PREPA prepared prepared an electronic system where customers can apply for an interconnection through the internet. And now what happens is that when a person wants to request an interconnection, we ask in that electronic filing all the information needed for us to have. For example, his location, the capacity of the DG system, all those, his name, all that information is included in that database, and now PREPA has that automatically from the registration of the customer. But then again, we have some concerns because Law 17 actually allows customers, to interconnect their systems, and then they can just inform PREPA, hey, I installed this, here's the certification, put the new meter to me, and so that I can apply, so I can benefit from net metering. And that's okay if that's the law. But the thing is that now we are like moving backwards in that regards if that person is not registering his PV system through the electronic system. Because if we are going to rely again back to a person actually from PREPA, including that information into the database, I think we're going back in time again. And that's what we wanted to avoid at that point. We wanted to avoid people from PREPA manually trying to put that information into the database because we don't have the necessary people now, for example, to do that. So that's why we think it would be wise for no matter what happens, that there's an electronic filing by the particular customer and that information is saved in this electronic system that PREPA has right now.
Thomas, practically, although the law said that no region is accepting manually documents, still the portal is online, and 100% of the filings are still because the portal has not been changed.
Yeah, but the thing is that I know that for some months, actually PREPA was receiving interconnections, and those interconnections were not necessarily passed through the electronic system that we have.
That was I think under Maria, under Hurricane Maria, the portal was shut down, the internet was not working, so they were accepting manual.
Yeah, I think but actually I believe that some regions did accept them in some regions until this summer, I think. Yeah, so that's the thing, but that's why we are encouraging people, to do the filing through the electronic system, and that helps them because that information is in there, it's filed, and it actually helps us to know where we are having DG systems, and that's going to actually, that information at the end of the day is going to be included in the GIS.
And I agree with you, by the way.
That's
that should be online, make it faster.
And just for what it's worth, if we're talking about the the mapping, and if there was the possibility of an icon of a PV on the map, I mean, just as customer privacy protections, as you consider the possibility that not only might we be talking about rooftop, we might also be talking about solar, we might also be talking about DER, just because PREPA has the data, just because, some folks might want to see that data, the customer's rights to privacy should also be respected. So, if I had an EV, I might not want other people to know I have an EV.
So what about just a dot? I mean, you have a dot, just a dot, okay. And then for the public to know, and then for the utility, they will know the specifics. So go ahead.
And I guess the only other thing I'd say is, I think it's great to be able to show the color coding. I'm just quite frankly shocked that there would be that level of detail of the circuits near the White House. Like from a security perspective, I am shocked about that. I know, I'm shocked.
Yes, and now let me give you my personal perspective. These are primary distribution lines. if I walk around the White House, I see the manholes, and I have a very good idea. I mean, there's truly nothing that it could be deemed sensitive that somebody with a Google search in regards to those lines. I mean, so what that's telling you is there are going to be distribution lines, and those are distribution lines.
So Jorge, as a point of view, I think there are a lot of different opinions about that out there. If you see, 3 circuit colors going through one structure, you've just told somebody where 3 circuits
Yeah, and
come together near the White
yeah,
House.
but so the public is, they do not rely on commercial power. So commercial power, they are okay. Yeah.
I think there are sensitive areas that the utilities might want to decide that in their models they don't represent. And some utilities are doing that. And so it should be part of a conversation about mutually acceptable approach.
And I would also ask, for the developers, how much value and how much detail do you need in a map? Like, having that level of detail of where the circuit is, do you really need that level of detail? Do you need to see that circuit level infrastructure for the entire island? Or if you're looking at the possibility of putting in a solar installation on this particular block, could you be limited or filtered to just see the proximity of the circuit relative to the... I'm just trying to figure out, is there a way to hedge it with maintaining security while also giving you guys enough information so that you can get what you need?
Any kind of response? Do you need that level of granularity? Is it required? Is it?
I'm gonna shoot a couple of answers because for example, the law is the law has one decision below 25 kilos, right? Mm-hmm. So for the 25 kilo and below, you have the 90% of the people trying to get connected, and that's an open gateway right now that is going to bring trouble for them, and is going to be like people urge us to answer in 30 seconds. So there's the need, and doesn't need to be that detailed. Just need to be efficient enough for us to not cramp their system with energy that cannot be absorbed. So actually, it's a planning tool, like we explained, but what we really need to have a go or no go decision right now. But then in the future, when that becomes more crowded, then it needs to have the detail enough, because then by every other block or mile, that feeder will be challenged by in a more intensive manner, maybe 6 years from now, in that same area, you'll have hundreds of systems.
Yeah,
and you would need that detail maybe 6 years.
I guess the nuance of my question is, in this picture, right? It's 1600 Pennsylvania Avenue.
Okay.
You have a specific address, and you could go in, you could see the map of that specific address, and you get that specific address detail that says, yep, that is, it's a green, and here's the price, and you get that information. But do you need to see the line that shows where the infrastructure is? Because what you just outlined is, I need to know specifically at that address. And I'm saying, if you still got that address, but do you need to see the line?
There was a fellow present like 6 or 7 presentations ago that explained that the law said that if there were to be an increment in capacity, there was somebody that had to pay it. So if there's money involved, there needs detail, because we need to explain to a client that there's going to be some expense.
So along those lines, in that case, so if the 1600, like if it was, okay, let's say it's $1,000. So if you were able to have an image of the line, just for that line, to prove to your customer But do you need to be able to have access to all 1,300 circuits in Puerto Rico as they currently exist to satisfy the need of that particular customer?
I think I have something that can be helpful. There's no consumer advocates here, but I do not think we're going to end up in a place where we have a map of every single address of every single person with solar on their roof that's public. I don't think that's appropriate. And it's definitely not needed from the solar developer's standpoint. All we need to know is it a green, yellow, or red light there right now? We came up with something in Missouri, where I'm from, and in Kansas City, when we had that might be useful here, where we had a rebate program, a solar rebate program that was just infinite money for a while, but then one day there was a cap put on it, $92 million. So it was really important to know, how much money is left in there. So we just came up with a system where every week or every day or whatever frequency it needed to be, there was a graph of 0 and 92 million, and it was red if it was already... checks were already cut, but it was yellow if they'd already been applied for, and then people would drop out if they didn't build it. And so, that's the sort of thing I think we need from a developer standpoint. But we don't need to know addresses, I don't think.
And I guess that's I'm just have my security hat on, that I just get really nervous about showing a map with the circuit and the physical infrastructure, and that's why I'm curious if there's a need for that. I mean, I get all the other dimensions of the cost and whatnot, but I just get really nervous from a security perspective.
And let me go ahead and say the following, because some people have been speaking here in regards to the critical electric infrastructure information that is attached to the bulk power system. We want to make a distinction between those requirements that are dictated by FERC for BPS into what it is where we are right now, which is the electric distribution system. In Puerto Rico, notably, let's forget about the District of Columbia right now. In Puerto Rico, most of the facilities are overhead. We can go to Google and we can see most of the lines. We can actually zoom into the transformer and see the kVA rating on the transformer. So keeping that into perspective, I think is very important to actually weigh security concerns, but also, what is already out there that you and I could see or not, right?
Yeah, I'm just saying, unless there's a compelling reason, why should it be made easier for anybody who has an ill intent?
Yeah,
that's right. That's why I'm asking. If there is a compelling reason as to why you need to have the lines, then great, that's the reason.
Right.
But if there's not a reason, then let's not make it easier.
Let's weigh it. Absolutely. Yeah. So two things that we need to do right now. So let's say that we capture the data and we hone out into what data we need. How often is this data, reasonably, we're facing in the data with the process. How often this data should be updated? I mean, I heard somebody saying that maybe once a year. I mean, this is a reasonable expectation for it to be once a year. In regards to the developers, is this okay? In regards to the utility, I mean, right. So, but it's a phase-in approach, right? So, we're talking days, weeks, years, decades. What would be reasonable? I heard 1 year. That would be the frequency of update. Does that seem reasonable for a phase one approach?
It should be commensurate in regards to the resources that I think that instead of putting, let's see what we have right now in the table, the resources. And after that, because the idea or idealistic can be something, but in reality, how much time will be something to understand.
And it might be useful to have Prepper share some information in the next session that talks a little bit about the frequency of the types of changes that they have on their system, because it's not unusual to see only a handful of circuits see significant enough change to impact hosting capacity within a year. And in some cases, in what some other jurisdictions have done, if they've done a yearly update, they've actually updated the DG in queue and DG connected at a more frequent basis, because that's essentially an extraction out of the database, not a recalculation of the hosting capacity. So something to consider that's been done elsewhere.
And Jorge, just something that I need to take out, and I was talking to Tomas on the side, there's a lot of cases that they have pending application, they are endorsed, which is approved technically, but they don't get to the final stage, and perhaps they have them on the system as active system. I think that also there should be a clearance about that, because that can be thousands of cases, but thousands of cases that the capacities are ready for.
Yep.
Jorge?
And then something else that I wanted to get from the group. So the buildup of the hosting capacity characterization, right, is going to be dependent on sensors. Right now, let's see what it is that the utility has in regards to power flows. Who should do that characterization? This is something that should be done organically within the utility, or this is something that maybe a third party should do for the utilities? Is something that maybe the PREP wants to consider to actually lead, and they actually will contract this out to somebody, and they will actually encourage, they will, what will be a good word? They will encourage the T&D operator to cooperate with this contractor. This is something that is so foundational that it should be within the organic domain of the utility, or this is something that should be explored for somebody else to do?
I think that there's a mandate by law that the Public Energy Office for the state is the one responsible to gather the data.
Well, but I'm talking about the hosting capacity characterization, building of those capabilities.
Okay.
Yeah. No, you could be right. I'm just being very specific. Yeah.
No, yes, but they're the one responsible to, because remember, when they draft the law, they're considering not one utility or one generator, they're considering, so they have this independent energy public policy office that is the one responsible to gather all the data and share and being in back and forth with the OEM first. That's why.
That's very interesting. So the thought is that the Programa de Política Pública Energética, because they're charge of the data, they should be the ones uploading maps and keeping the maps up to date. Mm-hmm.
The special composition of Puerto Rico is just showing us that there's only one utility. So actually, this is a driving tool for them also for planning. So, it needs to be safe, like he's saying. It needs to be a driver for them, but it needs to be also a qualifier for us to be able to insert projects and what have you. But intrinsically, it's for you guys.
Get this again. Let me see if I'm making sense out of this. So, the Programa de Política Pública Energética is in charge of displaying the data to the public, and then they get the data from the utility, and the utility is doing actually the characterization of the system. And maybe we don't need to have the answer right now, but maybe that could be the approach. If they're up, it's going to be up to them to show it to the public. So you got to believe it. They're going to be on the T&D operator door, making sure, hey, give me the data.
I believe it should be developed and nest. It should be a nest on the utility. But it's like typical things that we see technologically today. When you put a tab, it says can edit, can only view, can only change,
right?
Because the security of that information has to be it has to protect the privacy of the consumer or the prosumer.
Right. So in other jurisdiction, it's mainly the utility that will actually have the maps on their website. So is the thought to have the PPE to actually display on their website this information?
In accordance to the law, they need to section, hold on real quick, 3.4 letter O. This office shall identify the percentage of capability hosting capacity of the infrastructure in Puerto Rico to integrate in a secure and trustful and reasonable cost and identifying technologies for the blah blah in regards to the energy system.
Okay, so
Yes,
I think
so they can be told.
So I
then
think
they can show it.
I think this is an action item for this working group. We need to find out. This is very important because I mean, if the we need to find out who is tasked.
No. Can you share it on the team?
Yeah, put it on the Microsoft team, please.
The platform.
So this is something that we need to hone on to see who is actually in charge of performing the actual characterization. So in my perspective, and remember, the prep is the one that implements the law. So maybe we need to explore as a group to have the actual characterization and build up of the functionality within the utility domain, and then have the PPPE display the information and update it in their website. So that's something that we will have to work on.
Just share quickly, I learned yesterday that there's a new director of OEPPE, an architect named Giancarlo Oquindo. I haven't met him yet, but this could be a good thing to approach and say, hey, you want to get involved in this process?
Let me see that guy.
Because we have been talking all along about the utility actually building up the capability. I will be very surprised to have an entity like the PPE build up capabilities to characterize the system. So that's something that we need to figure out as a group. Any other kinds of comments? If you can actually go ahead and if you can on that worksheet put a couple of thoughts, that will be very appreciated. If there is anything else that you would like to share with the group today, it's been a long day, and you are the last good Puerto Ricans standing, and we appreciate that very much. So before we go, there are two things. There is if you can capture some of your thoughts in that worksheet. Really quick before you all go, if there is any kind of study, evaluation, analysis that pertain to the utility, please, that is available, that you could share with the public, please upload it to the Microsoft Teams. And right now, a question before we go, do you think right now we have spoken today, if there is any kind of gap in regards to an expert, a subject matter expert that we would like to listen to for future sessions? I heard somebody saying that we may want to have a session on AMI. So yeah, we're gonna follow up on that. Anything else that you think there may be a gap right now?
Maybe the expertise is already in the room, but to the extent of hosting capacity, projections, again, I'm just thinking of the hard data of what do we have now and where are we headed. What I'm seeing with the IIRP is projecting that 30% of the renewables is going to come from distributed generation. If that's true, then my back of the napkin calculations are that we need to have about 100,000 distributed generation systems connected by 2025. So going from 15,000 to 100,000, it is the law. Maybe it's unrealistic, but maybe we can do it. So what would it take to pull it off? So someone to talk about forecasting and say, well, this is legally the bare minimum. What would that take, and kind of reverse engineer to what we really, so forecasting.
So it might be an interesting conversation for 2 weeks from now when the planning session occurs, and talk about that, because scenario planning tied to legal and or regulatory goals is usually a key item that's discussed. And then there's the question of what do you operate on, and then what are the bounds? So it's interesting to see the results.
And speaking of overlap, I think AMI would overlap all three of these working groups as well, because it's just a foundational data source that is important for resilience, potentially for hosting capacity and for planning.
I have a question.
Joe, microphone please, so they can hear you.
Oh, excuse me, sorry. Does the subject of non-wires alternatives enter into this?
Right. So that will be planning coordination, and we're going to. Yeah.
Okay.
Yeah.
Okay.
Any other kind of thoughts? Any other kind of thoughts, or?
No. I have to go.
Okay, so listen, guys.
Not that.
Thank you. Yeah, I know we got some people. Some people that need to make some flight connections. Listen, guys, thank you very much for your time, for your commitment. We look forward to seeing you in 2 weeks. And we look forward to seeing you tomorrow on the Microsoft Teams. Thank you very much. We give you the most thankful appreciation for your time and your collaboration. And have a great weekend.